On September 18, 2025, a pair of seemingly unbelievable occurrences unfolded just 72 hours apart. The Kamchatka Peninsula in Russia trembled from a 7.8 magnitude quake, the most recent in a series of destructive shakes that started back in July. Yet 3 days prior, Earth endured a G3 geomagnetic storm triggered by the sun stirring from its 11-year rest. Mere chance? Maybe. But a third element enters this stellar saga, 3I Atlas, the cosmic intruder speeding toward our star, trailing a plasma tail half the sun's width and expanding daily. Whether for good or ill, we're observing a phenomenon unprecedented in human records. Join me as we delve into this evening's inquiry, probing if these remarkable incidents are mere flukes or signs of deeper links that science hesitates to explore. First up, the sun's revival. Earth quaked on September 18, 2025, as a 7.8 magnitude tremor tore through the seas off Russia's Kamchatka Peninsula, rippling shocks along the Pacific Ring of Fire. What elevates this episode to the extraordinary? Only 3 days before, our world faced a different assault, a G3 geomagnetic storm, among the year's fiercest space weather assaults, surging through our magnetic shield like an unseen tidal wave. 2 happenings in one weekend, bridged by a puzzle that would give any logical researcher pause. The probabilities? Consider this. Our sun is rousing. Following a stretch of calm, solar cycle 25 climbs to its maximum, with data painting a picture that's intriguing yet disquieting. The Space Weather Prediction Center at the National Oceanic and Atmospheric Administration monitors rising solar behavior, more coronal holes, swift solar wind flows, and magnetic disruptions sparking northern lights visible as far south as Colorado. Now, the twist. That G3 storm from September 14 to 15 didn't stem from a solar outburst or mass ejection. Instead, it arose from a stealthier, enduring source, a high-speed stream from a coronal hole. Picture the sun's magnetic lines blooming open like petals, forming a fast lane for charged particles to barrel toward Earth faster than 600 kilometers. The ensuing quake wasn't a typical follow-up either. This 7.8 magnitude strike hit the identical area ravaged 7 weeks before by an 8.8 magnitude behemoth, among the strongest quakes ever captured by instruments. The July 29th incident sparked tsunami alerts across the Pacific, with sensors from Hawaii to Chile tracking swells that might alter shorelines. Any credible seismologist will affirm that quakes arise from tectonic pressures, the gradual clash and shift of Earth's plates, sculpting our world over eons, and they're spot on. Still, could there be additional layers? Cue the third figure in our celestial tale. 3I Atlas, catalogued as C225NA1. This comet stands apart. It's the third verified interstellar guest to our solar system, a Voyager from interstar emptiness now racing for a near pass by our sun. On October 30, 2025, it hits perihelion, its nearest point to the sun, about 1.4 astronomical units distant. Before panic sets in about doomsday preps, rest assured, 3I Atlas presents zero danger to Earth. Its minimal distance from us will be around 1.8 astronomical units, or about 168 million kilometers greater than the Earth-Sun gap. No apocalyptic scenario here, rather, it's a chance for discovery. Yet what sets 3I Atlas apart is its Hubble Space Telescope imagery, uncovering something astonishing. This star-hopping body is already stirring to life. A comet is forming its coma, a hazy envelope of gas and dust in a region where most such bodies stay inactive. This feature could stretch across about 700,000 kilometers, nearly half the width of the sun. Pause and consider that. A visitor from a distant star system, loaded with chemicals and frozen materials born in a foreign stellar environment, is generating a vast zone of activity large enough to engulf multiple Earths with room to spare. And all this happens while it's still millions of kilometers away from the sun's heat. To be absolutely straightforward before we continue, conventional experts in seismology see no proven connection between solar flares and seismic events. The United States Geological Survey, the leading authority on quakes worldwide, insists that movements in the Earth's crust cause these tremors, not conditions in space. As we delve deeper, we'll examine other ideas, but we'll mark them explicitly as theories, not proven truths. Still, the sequence of events raises eyebrows. The geomagnetic disturbance on September 14th stemmed from a repeating trans-equatorial coronal hole, a lasting opening in the Sun's magnetic shield that had been sending fast-moving solar particles our way for several days. Solar researchers label this one CH1316, and it set the stage for various magnetic upheavals during the month. Streams of rapid solar wind from these holes differ from the explosive bursts we often link to space events. Rather than a quick jolt, they apply steady force over days. Particle counts in the wind can plummet, occasionally to less than 1 per cubic centimeter, even as speeds climb to almost twice the usual 400 kilometers. If you're keeping tabs from home, real-time data is easy to access. The National Oceanic and Atmospheric Administration's Space Weather Prediction Center offers ongoing reports on the KP index, which gauges magnetic disruptions on a scale of 0 to 9. Levels over 4 begin to impact tech systems. A reading of 6 or 7 might interfere with electrical networks and navigation signals. The United States Geological Survey provides equally open records of shakes, logging every event above 2.5 magnitude, breaking it down, and sharing it publicly almost instantly after it happens. When media buzz ramps up, and it surely will, these resources deliver reliable facts. Shifting back to our interstellar guest, 3I Atlas isn't navigating this dynamic region around the Sun by itself. The month of October 2025 looks set to be one of the busiest periods for spotting comets in years. Comet C2025 R2 Swan will swing nearest to our planet from October 19th to 21st, coming within 26 astronomical units, near enough for its tail to show up through binoculars. At the same time, C2025 A6 Lemon is growing brighter fast, with predictions indicating it might hit 4th magnitude by month's end. That makes it visible without aids on clear nights, if you pinpoint its spot. Several such wanderers, a lively sun, and our world shaking with some of its strongest quakes in more than 10 years. Mere chance? In the sections ahead, we'll look at concepts from certain scientists that suggest ties between these occurrences, potentially reshaping views on the solar system's linked dynamics. One undeniable reality: the Sun's magnetic influence stretches well past its glowing surface, forming a heliosphere that wraps around every planet and probes into the space between stars. When intruders like 3I Atlas cross into this area, they join an electric network covering billions of cubic kilometers. Their enormous comas can engage with the solar wind, the magnetic lines threading between planets, and the intricate flows of energy pulsing across our celestial neighborhood. The real issue isn't if these exchanges take place, they certainly do. The core question revolves around whether they possess sufficient strength to affect geological activities on a world 150 million kilometers distant, or if subtle shifts in the electromagnetic field enveloping us might tip the precarious equilibrium of tensions along fault lines. As we delve further into this exploration, we'll scrutinize 3 separate types of proof. First comes the confirmed information: space weather observations, earthquake logs, and astronomical sightings that everyone accepts without question. Next, the disputed assertions ideas, linking solar flares to seismic shifts that continue to spark fierce arguments among experts. And finally, the purely conjectural possibilities, those intriguing what-if scenarios that challenge established ideas. We kick off our inquiry by focusing on the Kamchatka Peninsula, a hotspot shaped by immense tectonic pressures into one of the globe's most quake-prone areas. Yet, as we'll uncover, even the simplest geological accounts spark doubts about patterns, groupings, and the enigmatic cycles dictating when our planet unleashes its pent-up power. What unfolds when a cosmic wanderer, towing a plasma formation rivaling the Sun's girth, collides with a solar setup gripped by magnetic turmoil? We're on the verge of learning. Part 2. The Kamchatka Swarm, an extraordinary barrage of tremors. Allow me to sketch the scene from July 29, 2025. At 14 hours, 55 minutes, and 10 seconds UTC, the ocean bottom near Russia's Kamchatka Peninsula abruptly moved. In under 3 minutes, a fault segment dormant for years unleashed force matching 32 billion tons of TNT. The ensuing 8 magnitude quake was so intense it altered Earth's rotation by mere microseconds. Moments later, alert networks for tsunamis throughout the Pacific activated. The DART system, designed to gauge and relay deep-sea tsunami info, picked up surges hurtling across the basin at nearly 800 kilometers per hour. Data from NASA's JASON satellites verified swells topping 3 meters in open waters, packed with destructive potential to devastate shorelines far inland. What sets this quake apart in seismic history, though, is its predictability, or lack thereof. Not entirely unforeseen, that is. The Kamchatka Peninsula perches atop a prime subduction boundary where the Pacific Plate plunges below the Yakutsk Plate at roughly 8 centimeters annually. This relentless clash has accumulated strain over ages, setting the stage for what experts term a megathrust quake. The setup for subduction in this spot is classic, ideal for sparking huge jolts. The sinking Pacific Plate forms a shallow angled rupture surface capable of breaking over hundreds of kilometers all at once. But once it yields, the upper plate rebounds like a taut spring, shoving vast amounts of ocean water aside. What caught everyone off guard was the remarkable series of big quakes that ensued. By mid-September, the area had endured over 40 tremors surpassing magnitude 6, some potent enough to rank as significant quakes independently. The magnitude 7.8 shake on September 18th marked merely the most recent in a chain that's riveted earthquake watchers globally to their screens. Grasping the significance of this bunching requires insight into how strain propagates through fracture networks. A big tremor doesn't merely discharge power, it scatters it anew. Zones once calm abruptly face heightened pressure, whereas certain spots enter so-called stress shadows, regions where the odds of quakes drop for a time. The difficulty with massive thrust earthquakes, such as the one on July 29th, lies in their potential to set off chain reactions over extensive regions. While the primary fault ruptures stretched almost 600 kilometers along the tectonic boundary, the resulting stress alterations extended even farther. Coulomb stress simulations from the United States Geological Survey indicate that numerous adjacent fault sections saw a heightened risk of rupture right after the primary quake. This marks the point where conventional seismology parts ways with unconventional ideas. The standard account for the September 18th quake is simple. It was a major aftershock sparked by the stress shifts from the July event. Its magnitude, 7.8 rating supports this view perfectly. Such secondary shocks are typical in sequences of this scale. Yet in scientific terms, timing matters immensely, and the schedule here sparks curiosity. The September 18th tremor struck merely 3 days following a G3 geomagnetic disturbance that passed through Earth's magnetic field. Is this just random chance, or might there exist a stronger link between our planet's electrical conditions and the physical forces behind seismic activity? Prior to delving into that notion, consider what unfolded during those pivotal days in September. The geomagnetic disturbance started on September 14th as a fast-moving stream from a coronal hole slammed into Earth's magnetosphere. In contrast to the abrupt hit from a coronal mass ejection, this exerted a steady force that ramped up slowly across 48 hours. Instruments on the ground detected magnetic field variations hitting G3 intensity, sufficient to spark broad auroras and slight interference with radio signals. Less obviously, the event generated telluric currents within Earth's outer layers, electric currents that trace along rock formations and can build to notable strengths near faults. The National Oceanic and Atmospheric Administration Space Weather Prediction Center chronicled the incident thoroughly. Solar wind velocities topped out near 700 kilometers, with particle counts falling below 1 proton per cubic centimeter. Such scenarios produce what certain experts term a solar wind void, a reduced pressure zone that, per some fringe theories, might affect plate movements via electromagnetic interactions. Caution is essential here. Within earthquake science circles, the concept of space weather prompting quakes is deeply debated. A thorough analysis in the Journal of Geophysical Research uncovered no reliable link between geomagnetic disturbances and seismic events once rigorous statistical methods were used. That said, a handful of investigations have noted faint associations in particular scenarios. Certain scientists highlight shifts in air pressure, ionosphere anomalies, or induced electric flows as possible catalysts for quakes on the brink of happening. The crucial term is on the brink. Nobody claims space weather can spark quakes in secure rock formations. The Kamchatka Peninsula in September 2025 was far from secure. The area was already dealing with heightened shaking after the July megathrust. Aftershock patterns generally adhere to proven statistical models, where event rates drop following power law distributions confirmed in countless quake series. What stands out about the September 18th shock isn't its existence. Big aftershocks are anticipated after magnitude 8. 8 ruptures, but its exact alignment with the geomagnetic event. Detailed stats would be required to assess if this alignment fits normal random patterns or hints at greater meaning. The underlying principles of how quakes might connect to such influences. Triggering earthquakes through space weather relies on various suggested processes. Geomagnetic disturbances might generate electrical flows in conductive rock formations, which could subtly shift fluid pressures along fracture lines. Alterations in atmospheric pressure from ionospheric warming may, in theory, impact crustal stress patterns. Certain scientists propose that electromagnetic influences might modify the dynamics of liquids in fault areas. Yet the key takeaway is this: even supposing these processes are valid, they would merely influence fractures already primed and on the verge of slipping. Space weather can't generate quakes from thin air. At best, it might hasten occurrences that were inevitable regardless. The insights into tsunamis from these incidents merit close examination. The July 29th quake served as a practical trial for cutting-edge alert mechanisms. NASA's Guardian platform, leveraging GPS to track surface movements instantly, delivered vital information mere minutes after the first break. Integrated with conventional seismic arrays and dart buoys, these tools offered an unparalleled view of energy transmission across the planet's interior and the water above. The surges from that July occurrence traversed the Pacific in under 10 hours, underscoring the alarming speed at which tsunamis span vast seas. Shoreline areas from Alaska down to Chile got early alerts, highlighting the global collaboration in tsunami research that has evolved since the catastrophic Indian Ocean disaster of 2004. Gazing ahead to the rest of 2025, experts in seismology keep a vigilant eye on the Kamchatka area. Predictive analyses indicate that further major aftershocks could still happen, with likelihoods fading gradually across the upcoming months and years. However, conventional forecasts overlook one factor. We're nearing an extraordinary alignment of celestial phenomena unlike anything documented before. An interstellar comet, its hazy envelope stretching hundreds of thousands of kilometers, is set to brush against a sun buzzing with magnetic energy at the height of its 11-year rhythm. Should interactions between space weather and tectonic shifts prove genuine, and that's a big uncertainty, the coming weeks might yield our strongest evidence yet. The debate isn't about mistaking links for causes, but about whether those links are robust enough to demand rigorous study. The ground under Kamchatka stays unsettled, its rupture zone still adapting to the immense strains from July 29th. Overhead, the cosmic weather turns more chaotic as solar cycle 25 climbs to its zenith. And out in the void amid the worlds, 3I Atlas presses on with its timeless voyage toward an encounter with our sun. What unfolds when these realms, geologic, stellar, and cosmic, overlap in such a tight time frame? The Kamchatka Peninsula might soon reveal the outcome, prepared or not. Part 3. The Earthquake Generator. An odd dynamic is unfolding in the space near our world that few ever consider. At this very moment, as these ideas reach you, our planet is enveloped by an unseen stream of ionized matter surging from the sun at velocities that could span the U.S. mainland in under 20 seconds. Known as the solar wind, it is swept by Earth for eons, but this stream varies. At times it surges ahead, others it lags, and occasionally it fosters such bizarre setups that a niche band of investigators thinks it might actually rattle the terrain under us. To grasp this, let's discuss coronal holes. Envision the sun's exterior not as a steady sphere of flame, but as an intricate magnetic terrain featuring both exposed and confined regions. Magnetic field lines typically originate from the sun and curve back toward its surface, capturing superheated plasma in graceful loops visible as solar prominences and dynamic zones. However, coronal holes operate differently. In these areas, the field lines extend directly outward into the cosmos, forming a kind of magnetic expressway that allows solar particles to flee unimpeded. This leads to swift flows of charged matter racing at speeds surpassing 700 km/s, almost double the typical solar wind pace. This is the point where things become particularly intriguing for those studying earthquakes. As these rapid streams approach our planet, they generate a phenomenon dubbed the solar wind vacuum by certain experts. The concentration of particles plummets sharply, occasionally dipping under 1 proton per cubic centimeter. For context, the atmosphere you're inhaling right now holds roughly 25 billion molecules in every cubic centimeter. This solar void is even more barren than the finest vacuums engineered in labs. A debated idea gaining traction among fringe scientific communities suggests these sparse conditions could trigger remarkable events. They could potentially draw major quakes from deep within the planet. The concept unfolds as follows. The planet's outer shell endures ongoing pressure from plate movements, with tension accumulating near fractures until they rupture. Yet, suppose outside electromagnetic influences could alter the moment of that rupture. Imagine if the charged atmosphere enveloping Earth, altered by solar wind patterns, delivered the subtle push required to set off quakes primed on the brink of collapse. The suggested process triggers a chain of electromagnetic interactions. Fast-moving solar wind flows provoke severe geomagnetic disruptions by squeezing and distorting Earth's magnetosphere. Such upheavals then spark strong electrical flows within the globe's conductive zones, the upper ionosphere and the lower conductive crust. Known as geomagnetically induced currents, these flows traverse the Earth's shell along routes of minimal resistance. These are established occurrences that power grid operators track closely as they risk harming transformers and eroding pipes. But might they also affect how faults behave? The notion isn't entirely implausible. Probing quake initiation remains a key focus in conventional earthquake science. Experts recognize that minor perturbations, like those from ocean tides, weather pressure shifts, or even pumping out underground water can hasten or postpone seismic events on faults nearing their limit. The key issue is if these electromagnetic forces pack enough punch to make a difference. Back in September 2025, Nature provided an impromptu test case, a lasting coronal hole labeled CH-135 channeled high-velocity solar wind our way over multiple days. Observatories tracking the solar wind captured the classic signs: heightened speed, lowered particle count, and ongoing patterns fostering extended geomagnetic unrest. The ensuing G3 storm wasn't the fiercest ever logged, yet it stood out for its length and the unique electrical signatures it produced. Earth-based sensors picked up variations lasting over 48 hours, as stations observing the ionosphere noted waves of disruption circling the world. 3 days afterward, a powerful magnitude 7.8 quake struck the Kamchatka Peninsula. Of course, mere association doesn't establish cause, and every reputable researcher will stress that core tenet. The tremor hit an area still reeling from vigorous aftershocks after the July magnitude 8 shock. Purely from odds, big follow-ups weren't surprising, they were anticipated. Still, the sequence of events piques the interest of those exploring such links. According to their studies of significant seismic events, indicate a pattern where they tend to occur in clusters amid phases of diminished solar wind density, conditions arising from streams originating in coronal holes. The suggested process unfolds in multiple stages. Initially, the diminished solar wind eases the external forces acting on Earth's magnetosphere, enabling it to broaden. This broadening alters the configuration of electrical current networks that traverse the interface between the magnetosphere and ionosphere. Such alterations in response influence the magnitude and patterns of telluric currents passing through the planet's crust in areas where fault lines meet conductive rock formations. In theory, these shifts might adjust pore fluid pressures, transform the conductive traits of materials along fault zones, or generate new zones of stress buildup. Although the impacts are minimal in overall magnitude, seismic activity proves highly responsive to even minor perturbations in stress on faults that are already near their breaking point. Evidence for these concepts stems from statistical reviews that juxtapose earthquake records with datasets on space weather. Certain investigations highlight links between the intensity of geomagnetic storms and the timing of quakes, whereas additional ones identify ties to particular solar wind attributes such as speed and sparsity. Nevertheless, conventional seismologists express profound doubt. The United States Geological Survey, custodian of the globe's most extensive earthquake records, explicitly asserts that no direct cause and effect link has been proven between space weather phenomena and tectonic disruptions. Backed by various independent evaluations, their stance holds that the apparent associations in select research fail to withstand rigorous statistical scrutiny. A key difficulty in this domain lies in distinguishing authentic patterns from mere data anomalies. Earthquake archives encompass vast numbers of incidents, while space weather logs capture ongoing fluctuations across numerous variables. Given the abundance of possible pairings, detecting seemingly meaningful links becomes commonplace, regardless of any underlying truth. Skeptics highlight various flaws in research linking space weather to quakes. Researchers' choices in selecting events or eras for examination can introduce bias. The pitfalls of multiple testing amplify the likelihood of uncovering false positives when probing a wide array of potential connections. Moreover, the hypothesized physical pathways frequently lack backing from controlled lab tests or mathematical models. Advocates counter that the consistent emergence of these links across diverse datasets, geographic areas, and analytical approaches points to a potential underlying reality. They cite instances where electromagnetic influences have demonstrably affected rock behavior in experimental setups, along with an evolving appreciation for the intricate and variable nature of Earth's electromagnetic surroundings. This solar wind vacuum theory stands as one effort to construct a mechanistic explanation for such findings. By zeroing in on precise scenarios like sparse, rapid solar wind flows from enduring coronal holes, it yields verifiable forecasts regarding peak times for space weather influences. As solar cycle 25 reaches its zenith, chances to validate these notions are on the rise. Coronal holes proliferate and endure longer at solar maximum, leading to more frequent brushes with swift streams. Concurrently, geomagnetic observation networks have achieved unprecedented detail, yielding precise readings of the electromagnetic context surrounding seismic occurrences. The September 2025 series provides a single instance within this continuing probe. An extended coronal hole produced ideal vacuum scenarios, trailed shortly by a substantial quake in a tectonically primed zone. Debate persists on whether this signifies true cause, mere association, or random chance. But what truly heightens the excitement for the coming months is this: we're facing far more than routine solar behavior. An interstellar object, trailed by a huge plasma tail, is nearing its nearest pass by our Sun. If the link between cosmic electromagnetism and our world holds true, 3I Atlas could soon deliver the most compelling evidence in modern records. The solar wind's void is no longer merely an abstract puzzle for astronomers. It's emerging as a key lens for observing how Earth reacts to the electric pulses of the solar system. As October 2025 draws near, that lens is set to widen dramatically. Even if you're skeptical about space weather sparking quakes, it's undeniable that the upcoming weeks will yield a wealth of information to scrutinize. The real issue is whether that information will bolster the void theory or debunk it once and for all. Regardless, The ground we stand on and the plasma streaming around our world are poised for an interstellar dialogue that might transform our grasp of the solar system's true mechanics. Part 4, Planetary Lineup and the G3 Tempest. At times, the cosmos displays a timing so impeccable it could rival a blockbuster film's plot. On September 13, 2025, Mercury hit Superior Conjunction, aligning perfectly behind the Sun from our viewpoint, forming an ideal linear path across the void. Just under a day afterward, a G3 geomagnetic disturbance slammed into Earth's protective shield with such intensity that it lit up the northern lights as far south as Kansas. Pure chance? Conventional solar science insists yes. The event stemmed obviously from a fast-moving solar windburst originating in a coronal hole, one monitored for days in advance. Mercury, positioned 96 million kilometers distant on the Sun's opposite side, had no conceivable impact on the solar wind conditions close to us. Yet, this is where alternative perspectives spark curiosity for those challenging standard views. Certain scientists suggest that celestial alignments could subtly alter the solar system's electrical dynamics in meaningful ways, not via gravity, which is negligible at those distances, but via the intricate network of electromagnetic ties binding everything in the heliosphere. To grasp this idea, envision the solar system less as separate bodies drifting in a vacuum, and more as an enormous electric network. The Sun anchors it all, spewing charged particles that generate flows across the entire heliosphere. Planets, with their magnetic shields and charged atmospheres, function as circuit elements, resistors, capacitors, inductors, on a grander scale than any engineered system. In this electric framework, when planets line up, they could tweak the heliosphere's total resistance. It's akin to tweaking parts in a gadget, which alters current paths and prompts unpredictable shifts in the setup. The Mercury alignment on September 13th stood out especially amid rising solar vigor. The Sun was nearing the climax of Cycle 25, marked by surging sunspots and frequent outbursts. Coronal hole CH-1316 had been directing swift solar winds our way for days, setting the stage for magnetic upheavals. Still, the disturbance hitting on September 14th exceeded many predictions in strength. Early forecasts pointed to a G2 level event, yet sensors on the ground detected G3 intensity fluctuations. That gap may appear minor, but in space weather contexts, it signals a major surge in electric power. G3 disturbances mark the threshold where cosmic conditions begin disrupting daily tech in tangible fashion. Aurora sightings turn vivid and widespread. Farther away from the polar regions, eyewitnesses noted occurrences as distant as Colorado and Illinois. Broadcast signals suffered interruptions, particularly in the higher frequency bands employed by air and sea transport sectors. GPS precision diminishes due to ionospheric disruptions that disrupt signals from satellites. Crucially for our inquiry, G3 level storms generate significant geomagnetic flows within the planet's crust. These telluric flows traverse conductive subsurface formations along routes shaped by subterranean water, mineral deposits, and various rock compositions. Such flows are thoroughly recorded in scientific literature. Utility providers have tracked them for years as they pose risks to transformers and can spark widespread electrical outages. The core issue is if these flows possess sufficient intensity to affect seismic activity. Engineers in the power sector express concerns over geomagnetically induced currents hitting hundreds of amperes in power lines. However, certain non-mainstream investigators assert that during intense geomagnetic disturbances, millions of amperes could course through the deep crust. The principles behind how these flows might initiate quakes are still hypothetical, though various theories have emerged. Currents passing through fracture zones might shift pore fluid pressures by altering the electrochemical traits of underground water. They could adjust the electrical discharge properties of fault rocks, increasing the chances of movement amid prevailing stresses. Alternatively, they may produce targeted warmth that weakens rock integrity at key points on fault surfaces. Conventional geophysicists dismiss these ideas, mainly arguing that the involved energy is negligible compared to the mechanical drivers of earthquakes. A standard magnitude 7 quake unleashes power akin to 32 atomic bombs, whereas the electromagnetic output from even fierce geomagnetic events represents mere slivers of that amount. Yet, initiating an earthquake doesn't demand equaling the full seismic energy output. Minor stress shifts, on the order of kilopascals instead of megapascals, can hasten quake onset when faults are primed near rupture. Tidal influences from the moon, for instance, can set off quakes despite their tiny mechanical impact relative to plate tectonics. The pivotal query is whether electromagnetic influences from geomagnetic storms deliver stress levels akin to those from tidal triggers. Lab tests indicate that electrical flows can affect rock-breaking mechanisms, though extrapolating to real-world fault networks proves difficult. What renders the September 14th event especially compelling is its alignment with the Mercury conjunction and the ensuing Kamchatka quake. Should celestial configurations influence the Sun's electrical environment, then such alignments could signal times of heightened electromagnetic links between solar activity and Earth-based phenomena. The process might unfold in this manner. Configurations among planets reshape the expansive form of the heliospheric current sheet, that immense spiraling electrical pathway originating from the Sun's equator and spanning the solar system. These alterations travel outward at light speed, arriving at Earth just 8 minutes after forming on the solar surface. When the altered sheet meets Earth's magnetic shield amid a geomagnetic disturbance, the resulting exchange could intensify beyond usual levels. The planet's field directs the boosted flows toward the poles, where they link into the worldwide network of telluric currents circulating through the solid ground. In seismically dynamic areas such as the Kamchatka Peninsula, these flows could in theory supply the extra push required to activate faults teetering on the edge. The impact would likely be understated. Perhaps this approach suggests shifting the onset of earthquakes by mere hours or days, without generating completely fresh occurrences. Examining this idea demands meticulous statistical review of earthquake records alongside geomagnetic storm logs and databases of planetary alignments. Initial research has noted faint links, yet experts in the field are split on their true meaning. The series of events in September 2025 offers a single piece of evidence in this continuing probe. Mercury's superior conjunction happened just under 24 hours before the G3 storm hit. The disturbance persisted for over 2 days, generating ongoing electromagnetic disruptions. 3 days following the start of the storm, a magnitude 7.8 quake struck the Kamchatka Peninsula. If there's any link beyond pure luck between these happenings, it stays unresolved. The gaps in timing hours from conjunction to storm, days from storm to quake, align with theories on electromagnetic triggers, yet they also match random chance. As solar cycle 25 hits its peak, chances to evaluate these concepts will grow. During solar maximum, coronal holes increase, leading to more clashes with fast solar wind streams. Planetary configurations happen often across the seasons, offering plenty of chances to assess electromagnetic influences. A key moment might arrive in late October as 3I Atlas nears perihelion amid various other celestial happenings at once. Should electromagnetic interactions between space weather and quakes hold true, this stretch could yield the strongest proof found so far. That said, it hinges on the impact staying mild and confined. Suppose they don't? Imagine if the electromagnetic setup during the October lineup packs enough punch to affect seismic zones in several areas at the same time. We're venturing into unknown ground regarding how space weather ties into Earth's dynamics. The Sun's activity level is the highest in years. Several comets are heading toward the inner solar system, while planetary setups are forming patterns unseen in historical records. The September incidents could merely preview a grander interstellar storyline. Whether that storyline plays out as mere academic interest or something with bigger stakes will hinge on inquiries we're just starting to frame. Part 5. The Antipodal Threat. Our world holds a graceful balance that few ever ponder. Trace a straight path from any spot on the surface through the planet's core and beyond, and you reach its antipode, the precise counterpart on the opposite side. For many locations, that spot lands amid vast seas. Yet, for the quake-prone Kamchatka Peninsula, a more captivating pattern appears. Its antipode lies strikingly near the Drake Passage, a hotspot of tectonic action in the Southern Ocean. This spatial quirk has drawn interest from scientists exploring energy equilibrium in worldwide seismic networks. Their theory is bold and mostly untested. Major quakes unleash stress shifts that demand eventual correction, and occasionally that fix happens on the far side of the globe. The idea blends solid physics with bolder geophysical ideas. We understand that big quakes send seismic waves circling the entire Earth. These waves, especially the extended period surface ones that can loop the planet repeatedly, deliver details on the quake's scale, depth, and fault break to every corner of the surface. But suppose they deliver more than data. What if they convey tangible stress alterations that build up gradually, setting the stage for later quakes in distant spots? Could seismic activity in far-flung areas, apparently disconnected from the primary quake, truly be linked? The powerful 8 magnitude tremor that struck Kamchatka on July 29th unleashed sufficient force to probe this concept. Detectors on monitoring equipment across all continents picked up its vibrations, with certain devices registering movements over 12 hours following the first break. Those vibrations orbited the globe several times until they faded into the steady hum of ongoing Earth tremors. Along the way, they traversed every significant fault network worldwide, encompassing the intricate web of sliding faults, diverging ridges, and sinking zones encircling the Antarctic seas. The area around the Drake Passage proves especially vulnerable, positioned where three key tectonic slabs, the Antarctic, South American, and Scotia plates, converge, fostering a region prone to building tension and erratic discharges. According to the antipodal theory, the Kamchatka event's power may have lodged within these southern ocean formations, setting the stage for a postponed seismic reaction. The exact process remains unclear. It might entail straightforward pressure shifts via the planet's inner strata, vibrational amplifications that heighten nearby strain points, or even unconventional interactions tied to Earth's magnetic influences and conductive framework. What draws advocates to this notion is the specific time frame they've pinpointed. Drawing from past records of opposing quake pairings, they propose that such follow-up shakes generally happen 2 to 6 months after the trigger. With the July 29th Kamchatka jolt, we're right in the midst of that period as we head into October and November 2025. Yet, it's wise to temper enthusiasm with caution. Conventional earthquake science dismisses antipodal initiation as an unproven idea. Organizations like the United States Geological Survey and similar bodies craft their predictions using nearby rock formations, buildup of strain, and data-driven approaches from local quake patterns. Worldwide pressure shifts do occur, that's solid accepted knowledge. Major quakes alter tension levels over vast expanses of thousands of kilometers, potentially speeding up or postponing ruptures on linked faults. However, these impacts usually fade quickly as distance grows, adhering to established equations rooted in fault shapes and crustal traits. Antipodal activation would demand power conveyance through 12,700 km of the planet's solid interior, the longest feasible span between surface spots. Although quake waves do span such lengths, the notion that they could build up enough strain to spark big events is still largely conjectural. The core issue revolves around assessing the energy involved. An 8 magnitude quake unleashes roughly 10 to the 17th power joules, akin to 32 megatons of TNT. Yet, the bulk of that gets lost as warmth and wave dispersal close to the fault's origin, within hundreds of kilometers. Only a minuscule portion arrives at opposite-side locales, dwarfed by the regional forces dictating quake risks. Still, those backing antipodal effects cite various past cases that appear to bolster their view. The Sumatra quake of December 2000 came before a 8.6 magnitude aftershock on the identical fault line just 4 months afterward. The Tohoku event in March 2011 was followed by odd tremors in various opposite zones, even if no standout major quake perfectly fit the expected outline. Even more fascinating, certain studies have spotted potential links between quake chains in the Pacific Ring of Fire and simultaneous stirrings along the Mid-Atlantic Ridge. These links, should they hold true, would propose mechanisms for stress transfer on a global scale that conventional seismology has yet to fully comprehend. The area around the Drake Passage offers a compelling example for examination due to its distinctive geological context. This waterway stands as the most recent oceanic corridor on the planet, forming just 34 million years ago as South America and Antarctica drifted apart for good. Given this fresh geological timeline, the local fault networks continue to adapt to their updated arrangement. The zone sees frequent earthquakes along the South American Antarctic ridge system, with common quakes measuring between magnitudes 5 and 7. Yet, the intricate interplay among expanding ridges, strike-slip faults, and the adjacent South Sandwich subduction zone sets the stage for potentially greater tremors. Should antipodal energy transmission prove valid, we could anticipate various indicators in the Drake Passage area over the next few months. A surge in earthquakes spanning diverse fault lines would point to widespread stress shifts instead of isolated impacts. Shifts in earthquake focal mechanisms or the alignment of fault planes could signal modifications in stress regimes, while the occurrence of significant quakes should align with the anticipated time frame for antipodal reactions. This hypothesis gains further depth from its electromagnetic dimension. Certain scientists suggest that triggering quakes at antipodal points goes beyond mere physical forces, incorporating electrical phenomena that travel via the planet's conductive strata. This notion ties the idea of seismic energy equilibrium to the wider electromagnetic frameworks under discussion. In this electromagnetic perspective, the Kamchatka quake generated not only physical stress alterations, but also electrical disruptions that spread through Earth's conductive mantle and core. Such disruptions might, in theory, affect seismic dynamics in antipodal zones via processes akin to those linked to space weather, including variations in pore fluid pressure, modified electrical rupture properties in fault rocks, or targeted thermal influences. The propagation speed of these electromagnetic signals far outpaces that of mechanical stress diffusion, which could account for certain brief correlations noted in past earthquake records. Electrical impulses move at substantial portions of the speed of light within conductive substances, allowing antipodal impacts to emerge in mere hours or days, not months. Validating these concepts demands advanced scrutiny of worldwide seismic archives alongside electromagnetic observation records. A few study teams have shared encouraging initial findings, though the broader scientific community stays cautious. The challenge lies in the low signal-to-noise ratio within global quake datasets, compounded by the array of factors that complicate proving direct cause and effect links. What renders this era especially captivating is the overlap of several possible triggering elements. There's the persistent aftershock series from the July Kamchatka event, heightened solar output during Cycle 25, and the nearing perihelion of 3I Atlas with its enormous electromagnetic tail. If antipodal triggering holds true, this blend of influences could form the most robust trial in documented records. The physical stress diffusion from Kamchatka, electromagnetic influences from solar phenomena, and conceivable exchanges with the interstellar object's plasma field might jointly affect seismic activity in various locales at once. The Drake Passage serves as merely one candidate spot in this framework. Additional antipodal zones tied to recent major quakes encompass parts of the Atlantic and Indian Ocean regions, where strike-slip fault networks might react to planetary stress variations. The crucial aspect scientists will keep an eye out for unusual activity patterns that surpass typical baseline levels, especially within the anticipated timeframes. As October and November 2025 unfold, experts in seismology globally will focus closely on these areas. Not due to a firm conviction in antipodal triggering effects, but rather because the overlap of numerous atypical elements forms a rare natural laboratory. Whether this setup supports unconventional seismic ideas or bolsters traditional views is yet unclear. Yet the information gathered in these months will surely advance our grasp of Earth's reactions to internal forces and external inputs alike. Our world is an intricate web of connections, where shifts in tension at one spot can affect dynamics over thousands of kilometers distant. Soon, we'll learn it might also react to forces from far beyond, even from interstellar voids. The idea of energy equilibrium posits that Earth sustains a seismic balance, with significant upheavals in one place prompting offsetting adjustments in others. If accurate, the July Kamchatka quake generated a disequilibrium that still seeks correction. The issue isn't if that adjustment will occur, it's about the location, timing, and our readiness to identify it upon arrival. Part 6. The Peculiar Interstellar Visitor. In the 1970s, the renowned astronomer Carl Sagan noted that in our cosmos, bold assertions demand robust proof. Measured against that benchmark, 3I Atlas poses a real enigma. This goes beyond a routine comet drifting across our solar system. It's a harbinger from the cosmos's depths, bearing elements and compounds born in the star-forming zones around remote stars. The official label reveals its essence, 3I Atlas, where the I denotes interstellar and the 3 marks it as merely the third verified outsider to our solar system. The initial one, 1I Oumuamua, puzzled researchers upon its 2017 arrival thanks to its elongated cigar-like form and odd speed-up. The follow-up, 2I Borisov, seemed more ordinary, a standard comet acting predictably during its 2019 transit. 3I Atlas sits midway between the ordinary and the remarkable, which heightens its fascination. Discovered first by the Atlas Telescope Network in 2025, it showed up as a faint blurred speck shifting amid the starry backdrop. Yet, path computation soon exposed its authentic character. Far from a standard asteroid or comet, its path was unmistakably hyperbolic, showing velocities and directions stemming solely from a birthplace well outside our sun's pull. Early sightings hinted at oddities with 3I Atlas right away. Usual comets stay inactive until nearing 2 or 3 AU from the Sun, about the span of the asteroid belt. However, this cosmic newcomer displayed activity at ranges where sunlight's warmth ought to have minimal impact. Images from the Hubble Space Telescope's initial close-ups verified suspicions from Earth-bound telescopes. 3I Atlas was forming a coma, the signature hazy shroud of vapor and particles that defines comets. Yet this haze emerged in scenarios where standard comet science implied it couldn't. Even more baffling were the shape specifics uncovered through prolonged study. In contrast to common comets, which form even, nucleus-centered comas, 3I Atlas exhibited forward illumination or leading-edge coma formations. The most luminous parts of its sheath seemed positioned in front of the core along its path of travel. This interstellar comet exhibits intricate patterns of gas release, influenced by its spin and varied surface features, which differ markedly from those seen in comets native to our solar system. The detailed spectral examination uncovered yet another unexpected finding. While typical comets here are primarily composed of water ice, accompanied by minor amounts of carbon monoxide and carbon dioxide, 3I Atlas displays a remarkably prominent carbon dioxide profile. Such a makeup aligns well with an entity originating in the frigid voids among stars, where carbon dioxide stays solidly frozen, whereas water ice could be diminished through numerous mechanisms. Yet it's the sheer magnitude of 3I Atlas that truly distinguishes it. Calculations of its core dimensions, based on Hubble imagery and heat-based simulations, point to a fairly compact body, likely measuring 3 to 6 kilometers in width. That's notable yet not entirely novel among comets. What stands out is the vastness of the surrounding haze it's generating. Recent data show the gas shroud around 3I Atlas reaching outward to a minimum of 348,000 kilometers from its heart, forming an almost round haze with a breadth of about 700,000 kilometers. For context, you could align almost 50 Earths edge to edge within the span of this cosmic wanderer's haze. This renders 3I Atlas similar in scale to some of the grandest formations in our solar system. Our Sun measures roughly 4 million kilometers across. In essence, the comet's haze covers about half the breadth of our central star. It forms a spectral, wispy sphere of vapor and particles meandering through the void, on a dimension that defies our usual notions of cometary forms. The mechanisms producing such an immense haze from a modest core involve elements peculiar to objects from beyond our system. In contrast to comets shaped by eons of sunlight and orbital tugs within our solar system, 3I Atlas preserves untouched substance from its birth stellar neighborhood. The blend of frosts it harbors might prove more reactive than familiar types, fostering intensified gas emission even far from the Sun. The body's spin contributes significantly as well. Initial sightings indicate a turning cycle of a few hours, common for diminutive bodies in our system. However, the arrangement of its outer layers could be quite uneven, featuring zones abundant in reactive frosts alongside others that stay mostly dormant. This mottled makeup might account for the uneven haze shape and the peculiar frontward glow effect. As 3I Atlas nears its perihelion on October 30th, the haze is bound to expand further. Greater solar warmth will sublimate additional surface and deeper frosts, possibly swelling the shroud to sizes that overshadow its already striking extent. Certain simulations predict the haze could stretch beyond 1 million kilometers wide, surpassing the Sun's own girth. What elevates this to a captivating level in space physics terms is that this vast haze isn't merely an inert veil of vapor and grains. It constitutes a dynamically charged plasma formation, engaging with the Sun's wind and the magnetic fields, threading interplanetary space in manners we've lacked chances to explore before. When particles from the solar wind strike neutral particles and compounds in the haze, they can eject electrons, generating charged particles that react to electric and magnetic influences. These fresh ions get captured by the solar wind and pulled from the comet, crafting the signature ion trail that stretches sunward. For a body whose haze covers hundreds of thousands of kilometers, this engagement area swells to enormous proportions. 3I Atlas effectively hauls a ball-shaped mesh across the solar wind, attuned to shifts in field intensity, particle counts, and plasma heat. It serves as a cosmic sensor for conditions in the heliosphere, reacting to solar activity and patterns that might yield unmatched revelations about the electromagnetic surroundings near our star. Its arrival timing is ideal for in-depth research. Solar Cycle 25 nears its peak, featuring more frequent solar eruptions, plasma expulsions, and swift solar streams. The heliosphere shows greater unrest and volatility than in over 10 years, offering 3I Atlas a diverse array of plasma states to encounter and analyze. NASA's James Webb Space Telescope observes the object's spectral changes as Earth-bound facilities track shifts in its hazy envelope and tail formation. The European Space Agency's Solar Orbiter craft is ideally placed to gather supporting data on solar wind patterns, while 3I Atlas navigates various zones of heliospheric turbulence. What unfolds before us amounts to a vast natural test in plasma dynamics far beyond any lab setup. An intruder from beyond our stellar neighborhood acts as a scout for our immediate cosmic space, uncovering hidden aspects of magnetic configurations and particle behaviors. Yet, 3I Atlas signifies beyond mere research potential. It highlights how our solar system connects to the broader galaxy. Such wanderers routinely migrate across stellar voids, bearing traces of chemistry and dynamics from far-off star clusters. We receive a delivery of extraterrestrial substances and principles straight to our stellar threshold. Some scientists now ponder if 3I Atlas transports implications deeper than curiosity alone. Its massive electromagnetic signature and odd responses to solar wind have sparked theories on whether these travelers could affect space weather noticeably. As we delve further, those ideas open doors to intriguing concepts regarding the nature of interstellar guests and their potential impacts during fleeting solar system transits. Meanwhile, 3I Atlas persists on its timeless path toward rendezvous with our Sun, intensifying in luminosity and vigor daily. Regardless of the enigmas tied to its remote beginnings, it prepares to unveil them in spectacular fashion. The cosmos delivers a herald from the interstellar voids. The sole uncertainty lies in our readiness to decipher its message. Part 7. The hazy sheath spanning half our Sun's width. Imagine a vast soap sphere drifting in the void, large enough to enclose 25 Earths with space left over. That's the magnitude involved in describing 3I Atlas's coma. This delicate shroud of vapor and particles has expanded to sizes that test our grasp of comet evolution. Recent infrared orbital observations depict a scenario bordering on the unbelievable. The coma reaches outward at minimum 348,000 kilometers from the core, forming an active domain about 700,000 kilometers in diameter. For perspective, in the grand scheme, this cosmic nomad has formed a cavity exceeding half the breadth of our Sun. Such a parallel goes beyond mere trivia in astronomy. It offers a glimpse into forces at play on immense scales we seldom witness. Our Sun, a colossal plasma orb bound by gravity, sustains core heat in the millions of degrees. In contrast, 3I Atlas consists of a modest icy rock fragment, likely no larger than a modest peak. Yet it crafts a formation matching our star's extent via entirely distinct mechanisms. Grasping this requires examining the essence of comet envelopes. The luminous crown we spot in the dark sky isn't the solid heart. It's a nebula of gas and dust grains released from the comet's core through solar warmth forms this structure. As icy solids transition straight from frozen state to gas via sublimation, they drag along fine dust, forming a growing sheath encircling the central body. In typical solar system comets, this mechanism starts subtly once they cross into Jupiter's orbital path, about 5 astronomical units from the Sun. The surrounding haze usually swells to its peak extent near perihelion, the point of nearest solar approach, before gradually fading as the body retreats to the system's outer reaches. Yet, 3I Atlas defies these standard patterns. It displayed cometary behavior even outside 8 astronomical units from the Sun, at ranges where solar energy ought to have minimal impact. This premature activation implies the presence of ices far more prone to evaporation than the water-rich mixes common in local comets. Spectral analysis reveals key details. Departing from native comets, which mainly consist of water ice laced with minor amounts of carbon monoxide and carbon dioxide, 3I Atlas exhibits a makeup led by carbon dioxide and various unusual compounds. These substances vaporize at far cooler temperatures than water, accounting for the object's ability to sustain a vast haze at considerable solar distances. Under terrestrial air pressure, carbon dioxide ice starts subliming near 78 C. In spaces near vacuum, this can happen at still lower temps, spurred by the weak rays of remote sunlight. Consequently, 3I Atlas has been persistently venting gases for months en route to perihelion, assembling its immense haze grain by grain. However, mere scale fails to convey the full oddity of this formation. The haze isn't a simple spherical cloud of gas and particles. Rather, it's a multifaceted, ever-shifting zone where diverse forces interplay at once. Solar radiation force drives tiny dust grains sunward, producing the signature dust tail that may extend millions of kilometers behind the comet. At the same time, the solar wind, a flux of charged particles surging from the Sun at 400 kilometers, engages with the haze's neutral gases via photoionization. High-energy solar photons colliding with neutral atoms and molecules strip away electrons, generating ions that react to magnetic influences. These fresh ions are then caught in the solar wind's flow and hauled from the comet at high velocities, shaping the bluish ion tail that consistently aligns straight away from the Sun, irrespective of the comet's path. For a body whose haze covers hundreds of thousands of kilometers, this ionization fosters an expansive arena of lively plasma reactions. Imagine 3I Atlas as hauling a gigantic web across the solar wind, one that's perpetually probing the magnetic surroundings near our Sun. Fluctuations in solar wind velocity, concentration, and magnetic intensity all shape the haze's reactions. In times of heightened solar output, such as the recent geomagnetic disturbances, these exchanges grow even more intricate and vigorous. The forward illumination seen in 3I Atlas introduces further intricacy to the scenario. Conventional comets form fairly even hazes focused on their core, but this extragalactic newcomer displays its most luminous zones in front of the nucleus, along its trajectory. Such unevenness indicates focused venting from particular surface zones, perhaps from the body's spin or uneven makeup. As 3I Atlas turns, varying parts of its exterior catch the sunlight, triggering intermittent releases that sculpt features inside the haze. These embedded patterns can linger for days or weeks, yielding an ongoing morphing tableau of vapors and debris. This phenomenon reacts to solar warmth as well as the body's inherent movements. The magnitude of such processes turns out to be remarkably grand once you factor in the rates of mass evaporation. Current projections indicate that 3I Atlas sheds multiple kilograms of substance each second while nearing its closest solar approach. That figure may seem modest at first glance, yet when prolonged across several months, it equates to thousands of tons of untouched cosmic matter spreading across the inner solar system. This ejected material retains the elemental markers from the stellar birthplace of 3I Atlas, formed eons ago. Examining the surrounding haze through spectroscopy yields a straightforward glimpse into cosmic compositions, delivering clues about stellar surroundings that no other method could reveal. Yet the haze offers far more than research potential. It constitutes an electromagnetic event of extraordinary proportions. The charged particles within the haze form a vast region where plasma behaviors unfold in scenarios previously unexamined. The interplay between this charged gas and the nearby magnetic fields might, in theory, affect space weather patterns across the inner solar system. Certain scientists are starting to ponder if visitors like 3I Atlas could function as innate regulators of space weather, their massive hazes acting as stores of charged particles that might intensify or mitigate electrical disruptions. Though this concept is largely conjectural, the immense scope of the affected area warrants serious thought. As the October 30th perihelion draws near, the haze is bound to keep expanding. Stronger solar radiation will sublimate additional icy layers, possibly swelling the shroud to sizes surpassing the sun's own width. Certain simulations predict maximum haze extents of up to 1.2 million kilometers in diameter, forming a feature grander than any fixed element in our solar system aside from the sun. Observing this colossal form from Earth is challenging, however. Regrettably, for all its vastness, the haze is highly scattered, with particle concentrations much sparser than Earth's upper atmosphere. Much of the substance clusters in the dust trail, which could appear to expert skywatchers using telescopes as the body swings past the sun. But the true spectacle unfolds in spectra beyond human vision. Radio instruments pick up signals from the charged elements in the haze, while infrared platforms follow the heat glow from dust grains warmed by solar rays. X-ray facilities observe intense energy events in the zone where the haze meets the solar wind. What unfolds before us is an unparalleled lesson in plasma dynamics, delivered by an interstellar guest. 3I Atlas has fashioned an organic lab for probing electromagnetic exchanges on vast scales unachievable in earthly settings, uncovering nuances of how substances and forces interact in the void encircling our sun. Emerging from these findings is an intriguing query. Could 3I Atlas transcend being a mere inert fragment of frozen debris drifting through the cosmos? Might a body generating such a profound electromagnetic imprint truly alter the very space weather it navigates? This prospect ventures into a domain blending rigorous science with imaginative conjecture, where lines between cosmic events and advanced tech start to fade, upending our views on universal possibilities. Part 8. What if 3I Atlas serves as an extraterrestrial power collector? Let's dip into unbridled hypothesis briefly, though one rooted in physical principles that may prove less implausible than initially thought. What if 3I Atlas is not merely a fragment of pure frozen stone? What if this object hails from a distant star system? Or perhaps it's even more astonishing an immense apparatus for gathering energy, crafted by an intellect beyond our comprehension, built to siphon power from stars as it journeys across solar systems. The concept might seem straight out of sci-fi, yet let's examine the clues we've explored. Its core is quite compact, maybe 3 to 6 kilometers in diameter, yet it produces a surrounding haze stretching 700,000 kilometers wide. Such a ratio of output to input would impress any designer. A body under 6 kilometers that expands into an operational area over 100,000 times its size. Viewed through the lens of energy harvesting, that vast haze starts to resemble not mere accidental venting, but an intentionally designed plasma sail. Picture a tech that unfurls a delicate web of conductive elements, ballooning to huge proportions while directing captured energy toward a central hub for processing. The underlying science holds up. We understand how electromagnetic forces can propel ionized particles to incredible speeds. That's the basis for plasma propulsion and magnetic fusion containment. Suppose 3I Atlas embodies an amplified form of these innovations, tailored for the plasma-rich zones near stars. The brightening at its leading edge that we've noted might indicate purposeful navigation tools, not just irregular surface traits. Should the craft employ regulated venting to adjust its path or enhance its engagement with the solar wind, we'd likely observe the very uneven patterns that have baffled stargazers. In this light, its abundance of carbon dioxide gains fresh meaning. Unlike water, which demands intense heat to vaporize, CO2 shifts straight from ice to vapor in the frigid voids of space. This property suits it perfectly as fuel for a device functioning over vast interstellar spans. Still, harvesting energy demands more than an expansive plasma zone. It would require ways to direct that energy productively. This is where the science turns fascinating. The mechanisms forming ion tails in comets could, in theory, produce vast electrical flows. As solar wind ions collide with neutral gases in the haze, they generate charged entities sensitive to magnetic influences. In ordinary comets, these ions drift off with the wind. But imagine if 3I Atlas housed built-in magnetic creators to steer those ions along defined routes. That setup could act as a gigantic magneto-hydrodynamic generator, transforming the solar wind's motion into usable electricity. The magnitude would be staggering, a capture zone spanning millions of square kilometers in a realm where particles zip along at over 500 kilometers. Crunch the figures, and the power potential is remarkable. At Earth's orbit, the solar wind delivers roughly 10.3 watts per square meter. For a haze as large as 3I Atlas's, that equates to gigawatt-level yields, rivaling scores of major power stations. Efficiency and conversion would be key, of course. Wild plasma exchanges waste much as warmth and light, yet a crafted device could surpass natural limits, employing superconductors or novel magnetic setups to boost energy yield. So, what might it do with gigawatts of harnessed power? One option is storing it, maybe by forming unusual matter forms or intense particle beams, systems capable of sustaining operations across vast interstellar expanses. One alternative involves dynamic propulsion, where the gathered power propels ejected material to alter the entity's path across the cosmos. Strategically, deploying a stellar power collector aligns perfectly with the goals of any society seeking to probe or settle the Milky Way. Celestial bodies offer the densest reservoirs of power in existence, and an innovation that harnesses starlight effectively would deliver massive benefits for voyages between stars. These apparatuses could fulfill diverse roles, including power accumulation, thrust generation, signaling, and research missions. They could function independently for eons, tracing planned paths from one stellar cluster to another, amassing information and supplies for their originators. The von Neumann probe idea, introduced by scholar John von Neumann in the mid-20th century, outlines autonomous replicators that propagate across the cosmos by drawing on substances and power from the star clusters they visit. 3I Atlas could embody a refined take on this idea, not reproducing itself, but enduring via star power extraction. Yet this is precisely the moment for critical scrutiny. Should 3I Atlas prove engineered, we'd anticipate markers setting it apart from ordinary celestial bodies, like atypical spectral readings, irregular heat emissions, or path deviations unaccounted for by gravity or gas releases. To date, the bulk of data on 3I Atlas aligns with typical comet-like actions, though exceptionally grand in scope. Its spectral profile reveals standard elemental and compound signals from vaporizing frosts. The path traces a parabolic course, possibly stemming from a gravitational launch out of a distant stellar neighborhood. The extra push noted in certain comets, such as 1I Oumuamua, might in theory arise from engineered drive mechanisms, Yet it could equally stem from uneven gas venting or unfamiliar natural dynamics. The definitive check lies in spotting tech indicators, synthetic substances, unified radio waves, or consistent action sequences implying purposeful guidance. Scans by radio observatories targeting 3IA Atlas have detected only routine signals from charged particle clashes so far. Nevertheless, lacking clear engineered traces doesn't automatically dismiss cutting-edge engineering. An advanced society could craft their scouts to imitate cosmic oddities, evading notice from primitive beings met en route. Such imitation might pursue various aims. Research-wise, to sidestep skewing studies of untouched environments, tactically, to dodge meddling with native societies, or defensively, to conceal the scouts' real strengths from aggressive encounters. Viewed this way, 3I Atlas's seemingly organic quality could ironically signal an engineered source. An invention built to siphon star power incognito would have to flawlessly emulate the traits of everyday space wanderers. Its entry timing amid peak solar cycle 25 might just be chance, or it could signal prime harvesting windows. An advanced scout could schedule its closest solar approach to match heightened star flares when plasma flows yield the most abundant power sources. The radio disturbances examined in this probe gain fresh relevance here. Were 3I Atlas drawing solar power deliberately, it could produce radio traces affecting atmospheric patterns across the Sun's nearer realms. These impacts might well be deliberate, maybe crafted to such correlations with earthquakes, could stem from probing the reactive traits of planetary magnetic fields, or might just be inevitable outcomes of vast-scale energy extraction operations within the heliosphere. The seismic links we've scrutinized may indicate a responsiveness to these electromagnetic indicators, as opposed to mere reactions to typical cosmic weather fluctuations. If 3I Atlas is altering nearby space weather via its power-gathering operations, Earth's systems could exhibit reactions that seem enigmatic if we chalk them up solely to natural origins. This hypothesis opens doors to even wilder notions. What if seismic activation isn't an unintended byproduct of extraterrestrial power collection, but instead a purposeful evaluation of a planet's quake mechanisms? Might 3IA Atlas be performing a methodical assessment of our world's crustal reactions to electromagnetic inputs? This notion stretches far past standard scientific paradigms, venturing into realms that many experts would label outright imagination. Yet, as we'll delve into shortly, the prospect of targeted energy influences, be they organic or engineered, sparks deep inquiries into the essence of the occurrences under our lens. Regardless of whether 3 Atlas is a relic of cosmic ice or a pinnacle of otherworldly design, its traversal of our solar system offers a rare chance to witness plasma dynamics at magnitudes we've yet to experience. The real issue is our readiness to identify what unfolds before us, no matter its true essence. Part 9. Earthquakes as Directed Energy. This is where our probe steps into ground that would likely spike the stress levels of most quake specialists. What if the seismic sequences we've followed aren't haphazard crustal happenings tied to routine space weather? What if they signal something far more disturbing? Intentional energy applications, methodically testing Earth's shell responsiveness with the accuracy of a lab trial. At surface level, the concept feels ridiculous, but reflect on the trends we've already mapped. Swift solar wind flows generate sparse vacuum states that certain studies suggest can set off quakes along stressed fault lines. The temporal alignments are compelling, even though the underlying physics face skepticism from established science. But suppose those vacuum states aren't wholly organic. Imagine if sophisticated tech could tweak solar wind traits, generating exact electromagnetic setups to sway quake behavior across a globe. This demands viewing energy and data flows on levels that defy our gut instincts. We typically see quakes as erratic, unforeseeable upheavals fueled by gradual tectonic buildup spanning years or eras. Suggesting external magnetic forces could spark them clashes with core principles of crustal dynamics. Still, the energy assessments aren't quite as far-fetched as they initially seem. Large quakes unleash massive power akin to scores of atomic blasts. However, that power was pre-stored via plate movements. Sparking it off doesn't demand equaling the full release. It just needs a minor extra push to breach faults teetering on the edge. Lab trials have shown magnetic fields can shape rock-breaking behaviors in set scenarios. Currents passing through stone specimens can modify their structural traits, shift pore fluid pressures, or induce spot heating that tweaks rupture points. The core query remains: can these small-scale lab outcomes expand to sway real-world fault systems? If a sophisticated technology aimed to investigate Earth's seismic networks, deliberate activation tests could yield priceless insights. Through generating deliberate electromagnetic scenarios and monitoring the ensuing ground movements, this setup might chart stress buildup along faults, the planet's crustal makeup, and how tensions propagate with remarkable accuracy. History offers a few compelling clues to fuel this idea. For instance, as Oumuamua swung nearest to the Sun in September 2017, a catastrophic 8.2 magnitude quake struck Mexico mere days afterward. Similarly, the March 2011 Tohoku rupture happened amid heightened solar flares, with multiple intense geomagnetic disturbances in the weeks leading up. Such links don't confirm anything definitive. Naturally, tremors happen often, and cosmic weather flares up routinely near the peak of solar cycles. Spotting seeming ties between celestial happenings and ground shakes is practically unavoidable across years of records. Yet things get more compelling when examining how big quakes cluster worldwide amid atypical space phenomena. The 2004 Sumatra jolt, the 2010 Chilean shakeup, and the 2011 Japanese catastrophe all unfolded in solar phases marked by intensified atmospheric disruptions. Even more fascinating, certain incidents displayed odd warning signs, hinting at outside influences over standard plate shifts like shifts in underground water, odd electrical signals, and weather oddities starting days or weeks prior to the big events. These are all effects that might stem from methodical electrical scans of the Earth's outer layers. Should Oumuamua turn out to be a high-tech scout instead of just a rogue comet, its vast electrical signature could serve as a perfect base for running these kinds of trials. The thing's huge, hazy envelope forms a charged gas zone bigger than many worlds, potentially directing and sharpening electrical impacts over vast stretches of space, spanning millions of cubic kilometers. The tools involved wouldn't have to break established science. Twisting magnetic fields via superconductor loops might produce beams that zero in energy on targeted spots on the globe. Devices pumping charged particles could tweak the sun's wind flow, setting up low-pressure zones that experts link to sparking quakes. The exact timing noted between cosmic storms and Earth rumbles might show deep knowledge of how the crust builds tension and releases it over time. A cutting-edge watcher could keep tabs on fracture lines non-stop, biding time for prime windows where tiny electrical nudges spark massive quivers. This operation could deploy various methods at once. Rapid electrical bursts might tweak the conductivity in rupture areas. Slower magnetic shifts could spark ground currents that tweak fluid buildup in rocks. Dumping charged gases high up in the atmosphere might generate pressure ripples that filter down to tweak tensions in the crust. Hitting the mark doesn't demand laser-like focus. Fracture webs are tangled setups where a nudge in one spot can set off chain reactions over hundreds of kilometers. A setup generating wide-area electrical quirks could sway quake trends broadly, skipping the need for spot-on hits. Still, what might drive a superior society to run these tests? Reasons could span simple inquisitiveness to hands-on worries over making planets livable or spreading resources wisely. Grasping seismic dynamics, such surveys would prove essential for any society eyeing the settlement of other worlds. Seismic activity patterns offer insights into the planet's crustal makeup, the spread of resources, and enduring geological reliability. A thorough analysis of earthquakes might pinpoint ideal spots for building vital facilities, steering clear of zones vulnerable to devastating earth shifts. From a darker angle, the power to induce quakes on demand could emerge as a supreme tactical asset. Being able to wreck shoreline metropolises or sabotage key facilities via distant electromagnetic control would grant massive influence in interstellar negotiations. The moral ramifications are profound. Artificially sparking large-scale tremors would unleash humanitarian fallout too vast to quantify. The 2004 Indian Ocean tsunami claimed almost 250,000 lives. The 2011 Tohoku catastrophe triggered several nuclear plant failures. The notion that disasters like these could stem from extraterrestrial trials is nearly too nightmarish to dwell on. Still, it compels us to grapple with troubling inquiries regarding the events we've noted. Links between cosmic weather and ground shakes, odd scheduling of occurrences, the rare alignment of celestial happenings amid solar cycle 25, these might signal deliberate probing instead of random chance. The difficulty is separating intentional impacts from ordinary processes we haven't grasped completely. Sophisticated plasma dynamics at solar system-wide levels could generate outcomes that seem engineered from our narrow viewpoint. Routine exchanges between vast comet tails and solar winds might yield electrical traces resembling engineered devices. The decisive check would involve spotting sequences that unmistakably point to deliberate intent over random fluctuations. Coordinated strikes on particular fault lines, exact synchronization aligned with peak strain buildup or electrical signals displaying artificial traits instead of organic ones. To date, the quake patterns we've tracked fall inside typical natural bounds, though their alignment with space weather incidents hints at more. The Kamchatka Peninsula's big tremors hit an area already primed by tectonic forces spanning eons. Yet the October perihelion flyby of 3I Atlas could offer a sharper evaluation. Should this body embody cutting-edge tech over a mere comet, its nearest solar encounter might spark amplified electrical disturbances capable of swaying quake risks in detectable fashion. Today's worldwide quake detection setup is more thorough than ever. Shakes exceeding magnitude 4 get flagged in moments by various outposts, yielding top-tier detail on onset, position, and origin dynamics. Should focused energy influences be at play, the October window ought to expose sequences that set them apart from routine Earth movements. Electromagnetic tracking tools are just as advanced. Magnetometer arrays cover the planet, and orbital platforms deliver non-stop data on space weather across the solar system. Any engineered tweaking of electrical fields should produce detectable marks separable from routine sun-driven or Earth magnetic shifts. The unsettling core of this theory goes beyond the chance of man-made quakes. It's the revelations it would bring about our grasp of the cosmos. Uncovering that seismic upheavals might arise from off-world tech would. This convergence fundamentally upends our preconceptions regarding planetary defense and humanity's role within the broader cosmic network. It implies that societies capable of traversing the stars could regard worlds like ours as ideal testing grounds for trials that might unleash catastrophic humanitarian crises upon the locals. The moral guidelines shaping such endeavors would likely be as foreign as the tech behind them. On a brighter note, consistent earthquake tracking could serve as a type of global assessment, collecting insights into crustal makeup and Earth processes that hold potential for upcoming joint research efforts. Any induced tremors, assuming they exist, could be regrettable yet accidental byproducts of valid inquiry. In reality, our grasp of the underlying physics is too limited to draw firm conclusions on what qualifies as organic versus engineered. The exchanges between enormous comet atmospheres and the Sun's plasma field delve into cutting-edge territory where our models are still evolving. Our best course is to keep observing with the finest tools available, scanning for trends that uncover the essence of these sightings. The coming weeks promise observations that may transform our view of the solar system's linked electromagnetic dynamics. Regardless of whether the findings back everyday causes or hint at stranger scenarios, they'll enrich our comprehension of events unfolding across vast expanses we can't mimic on Earth. The cosmos runs trials we're just starting to figure out how to track and decode. The issue isn't if targeted energy influences occur, it's if we're astute enough to spot them when they do. With 3I Atlas nearing its solar rendezvous, we'll soon gain our fullest glimpse into plasma behavior at immense stellar levels. Should these views disrupt our ideas of natural limits, we'll have to ready ourselves to broaden our perspectives, potentially forcing a deep reevaluation of our spot in the galactic expanse. Part 10. The October Nexus and the Hidden Threat. October 2025 looms as one of the most pivotal astronomical phases in documented annals. A clustering of sky happenings that echoes the dire prophecies of old scrolls. Yet, unlike the wild visions of end-time seers, these stand as genuine celestial occurrences, accurately predicted and empirically confirmed. The debate isn't over their occurrence, but their implications for Earth and our insight into the solar system's true mechanics. At the heart lies the new moon on October 21st, when our moon slots precisely between our world and the sun. Such alignments happen routinely each month with unerring regularity. What sets this one apart is its overlap with multiple key celestial setups, forging a setup unseen in historical records. 30th. Atlas hits its perihelion on October 30th, swinging to about 1.4 astronomical units from the Sun. Though safely beyond Earth's path, more distant than Mars at opposition, it's near enough for the comet's vast envelope to clash vigorously with the escalating solar wind turbulence as Cycle 25 climbs toward maximum. At the same time, comet C-25R2 Swan draws nearest to Earth from October 19th to 21st, skimming within Oort, 26 astronomical units. That's about a fourth of the Earth-Sun span, near sufficient for its emerging tail. When observed through binoculars, it stretches across multiple degrees of the heavens. This alignment forms what certain scientists term a reconfiguration event. Several celestial entities are positioning themselves in patterns unseen since the advent of contemporary space weather tracking. It's akin to the cosmos offering a spontaneous trial in stellar electromagnetism, crafted to probe hypotheses on how heavenly dynamics could affect earthly phenomena. What renders this phase especially captivating from a research angle is that we're beyond typical comets, tracing familiar paths. 3I Atlas transports elements and substances from a distant stellar realm, possibly reacting to solar warmth in manners unlike any in our neighborhood's comet array. Its enormous carbon dioxide-laden envelope marks unexplored ground in plasma science, a formation that might engage with the sun's atmospheric layers in entirely novel fashions. For earthbound watchers, the observation conditions bring both prospects and hurdles. 3I Atlas will linger on the sun's opposite side through much of October, blocking direct views from our planet's surface, yet orbital observatories keep tracking its evolution, and its electrical signals persist via radio and X-ray detections that cut through the sun's brilliance. Comet Swan provides superior chances for hobbyist stargazers, its tail already spanning about 2.5 degrees in the sky, roughly 5 times the moon's diameter. A striking display for those in clear, unlit areas equipped with simple viewing tools. As it nears perihelion, the tail could emerge to unaided eyes in spots shielded from urban glow. Of greater note, these bodies will mingle with solar wind patterns, growing more volatile near the sun's peak activity cycle. Lately, we've witnessed severe G3 geomagnetic disturbances, heightened solar eruptions, and high-speed streams from coronal voids conditions, some experts link to seismic initiation. This blend of elements amounts to an innate trial run for concepts on space weather's impact on ground-level events. Should links between solar sphere states and quakes hold true, October's setup could yield our strongest proof yet. Seismologists worldwide are eyeing this stretch closely, not out of firm conviction in solar-triggered tremors, but due to the extraordinary mix of factors: diverse sky objects, intensified sun behavior, and Earth still recovering from the intense strains of July's Kamchatka quake. Such interplay ought to uncover key insights into their mutual effects. On a more conjectural note, certain scholars suggest this October setup signals a celestial reboot, a juncture where orbital forces shift to fresh setups, potentially shaping space weather flows and Earth's magnetic surroundings. This notion draws not from proven science, but from spotting trends in ancient sky logs. Viewed through a symbolic lens rather than empirical, the October 21st new moon falls in Virgo by modern sky mappings. While old astrological views might assign it to Libra, accounting for Earth's axial drift across ages, these interpretive systems sway no material outcomes, though they've long served as lenses for humanity to make sense of heavenly happenings. The psychological effects of these celestial alignments must not be overlooked. When several striking astronomical phenomena coincide, they foster a profound feeling of universal importance that can tangibly shape human actions. Stock exchanges, societal shifts, and personal choices all exhibit notable fluctuations linked to eras of intense stellar spectacle. Yet, shifting back to the more rigorous aspects of research, the theory of a debris path linked to 3I Atlas introduces further intricacies to the October outlook. Initial estimates indicate that our planet could cross paths with streams of dust and fragments from the object's journey around 2026, possibly sparking a meteor display from extraterrestrial sources. Should these interactions happen, they would offer humanity's initial chance to examine substances from a distant stellar realm right here in earthly labs. Examining the makeup of those fragments might uncover insights into starbirth mechanisms, the makeup of space between systems, and the environments prevailing in the interstellar gaps. That said, it's vital to stress that no government space organizations have verified any risky fragment meetings tied to 3I Atlas. The path of the entity stays far from our planet's orbit, and its particle output seems to adhere to standard comet behaviors, even given the exceptional magnitude. The true mystery here lies in how diverse electromagnetic forces will interact at the height of the action. Influences from solar winds, various comet plasma zones, and our world's magnetosphere form a complex three-part challenge in cosmic physics that defies exact mathematical resolution. Simulations on computers offer approximations, yet the true dynamics will emerge solely from direct watching. The perihelion swing on October 30th marks the pinnacle of 3I Atlas's detectability by orbital observatories. As it swings nearest to the Sun, intense solar warmth will sublimate its icy layers at peak speeds, likely swelling the surrounding haze to sizes surpassing the Sun itself. The chances for spectral analysis in this phase are without parallel. All leading solar-capable telescopes in space will train on 3I Atlas, collecting information on space-based reactions, charged particle exchanges, and magnetic configurations previously out of reach. Earthbound radio arrays will track signal bursts from the clash area as X-ray facilities follow intense energy events in the comet's charged parts. The findings from this time will undoubtedly occupy experts in plasma science for years as they puzzle over the sightings. Viewed from our world, the central issue is if any of this stellar theater will manifest as detectable impacts on ground-based networks. The quake links we've examined, the magnetic irregularities from solar disturbances, and ideas on cosmic weather-sparking tremors will undergo their toughest trial amid the October overlap. Should cosmic weather truly sway quakes, this stretch ought to yield unmistakable proof. If not, the lack of ties during such a bustling celestial moment would largely debunk the notion. In any case, we're on the cusp of solid resolutions to long-standing disputes. The hidden risk isn't so much an imminent disaster. Rather, it's the chance we uncover that our grasp of solar system operations is far patchier than assumed. The cosmos is set to run a grand trial in stellar mechanics on an unprecedented level. If we're equipped to interpret the outcomes is still up in the air. But prepared or otherwise, October 2025 will transform our understanding the electromagnetic surroundings we live in and our role amid the broader cosmic network. The alignment is approaching, bringing resolutions to inquiries we've just begun to formulate. Part 11, the complete comet cluster. If you imagined 3I Atlas journeying solo across this vast stellar stage, get ready for a profound shift in your viewpoint. The closing months of 2025 are hosting what scientists describe as a comet cluster, 7 separate bodies gathering in the inner solar system at the same time, forming the densest and most observationally valuable era for comets in recent history. Allow us to introduce the entire lineup of this heavenly spectacle, each one contributing its distinct traits and puzzling scientific enigmas to the show. Leading the pack is 3I Atlas, the interstellar giant boasting a huge carbon dioxide envelope that stretches across half the Sun's width. It reaches perihelion on October 30th at 1.4 astronomical units with its nearest pass at 1.8 astronomical units. This extraterrestrial guest keeps challenging standard comet dynamics, staying active in regions where typical comets stay inactive. Next up is C2025 R2 Swan. Likely the most striking sight in our group, it makes its closest pass by Earth from October 19th to 21st at only 26 astronomical units. This comet has already grown a tail spanning 5 degrees in the sky. That's equivalent to 5 full moons' worth of ethereal vapor and debris. Spot it with binoculars, and it might even be visible to the unaided eye from clear, dark sites. C2025 A6 Lemon stands out as our fast-changing newcomer. Early estimates predicted a subdued display, but fresh data indicates it's growing brighter far quicker than expected. Projections now indicate it may hit 4th magnitude by late October, making it detectable without aid in decently dark conditions. Lemon's swift changes have made it a hit with hobbyist stargazers monitoring its progress each evening. C2025 K1 Atlas, distinct from our interstellar arrival, hit perihelion on October 8th. This standard comet offered prime viewing chances in early fall ahead of the big October gathering, acting like a prelude to the upcoming astronomical highlight. 210P Christensen takes the spotlight in early November, embodying the recurring comet type in our collection. In contrast to the extended orbit newcomers on their debut visits, Christensen adheres to a reliable path that returns it to the inner solar system periodically, every few years. This routine quality positions it perfectly as a reference for examining the odd patterns of our interstellar and long-orbit guests. 24P Eschamas carries the show through late 2025 and into early 2026, ensuring a seamless transition as the primary October cluster fades. This recurring comet's prolonged presence allows researchers to explore how various bodies react to shifting solar wind patterns amid the advancement of solar cycle 25. Lastly, we must note C2024 G3 Atlas, a prior 2025 highlight that delivered breathtaking sun-grazing views before our present group formed. Though inactive now, its previous transit set key benchmarks for space weather effects, aiding our analysis of the ongoing cluster. The physics behind comet tail formation offers vital insight into our observations. Comets actually produce 2 separate kinds of tails via entirely distinct mechanisms. Their interaction uncovers specifics about the comets themselves and the space they're navigating. Dust tails emerge from the straightforward effect of solar radiation pressure. When sunlight hits minuscule grains released from the comet's core, the photons impart motion, gradually pushing the dust outward from the comet. Bigger grains. Larger comets experience reduced sensitivity to this force compared to their smaller counterparts, resulting in the distinctive arched shape as varied particles trace out subtly divergent paths. Ion tails function via electromagnetic influences instead of radiation pressure. High-energy photons from the Sun strip electrons from neutral atoms and molecules within the comet's surrounding atmosphere, generating charged particles that swiftly align with the magnetic structures carried by the solar wind. These ions are then carried off from the comet at extraordinary speeds, forming the linear bluish tails that consistently extend straight outward from the Sun, irrespective of the comet's path around it. This differentiation proves essential when several comets are present at once amid fluctuating solar wind patterns. Every body encounters a marginally unique electromagnetic setting, offering an ideal setup for exploring plasma dynamics over enormous volumes of space spanning millions of cubic kilometers. In times of heightened solar output, such as the geomagnetic disturbances we've encountered lately, the dynamics of ion tails turn especially striking. Ejections of coronal mass can outright sever ion tails from their originating comets, an event vividly documented by satellite imagery of comet Enkei in 2007, where a solar outburst fully detached its plasma tail. Conditions at the peak of solar cycle 25 heighten the chances of such separations as our cluster of comets nears its closest solar approach. The way each comet reacts to space weather disruptions yields invaluable insights into plasma concentrations, magnetic intensities, and electromagnetic instabilities that no other method could capture. For those observing as hobbyists, this cluster presents remarkable chances to observe comet changes unfolding live. The notable extension of Swan's tail offers targets visible through binoculars that shift appreciably between evenings. Lemon's swift increase in brightness serves as a dynamic subject for imagers and naked-eye watchers following its progress. Experts in astronomy share this enthusiasm for the research potential. The diverse makeup, orbital varieties, and activity intensities in the group allow for built-in comparisons in cometary science. Examining the interstellar Guess 3I atlas alongside local solar system residents like Christensen uncovers key variations in frozen materials and the ways they release gases. Orbiting telescopes are prioritizing comet studies right now. The James Webb Space Telescope has allocated key observation periods to spectral examinations of these bodies, aiming to decipher variations in their makeup and what they reveal about how our solar system came to be. The Hubble Space Telescope keeps up its close watch on shifts in comet atmospheres and tail formations. Its superior imaging resolution uncovers fine details in the gaseous and dusty layers that Earth-bound telescopes can't distinguish. Radio arrays detect signals from the charged parts of comet atmospheres, while X-ray facilities observe intense interactions where comet plasmas meet the solar wind. Linking data from these various spectral bands yields full views of how these celestial bodies engage with their cosmic surroundings. Viewed through the lens of space weather, the cluster establishes numerous monitoring sites across the inner solar system. Each comet's plasma zone reacts instantly to solar wind variations, delivering spread-out readings of electromagnetic forces, particle counts, and magnetic chaos over expansive areas. The information gathered promises to transform our grasp of the Sun's surrounding sphere for years ahead. We've never before witnessed such a multitude of organic plasma sensors active together amid intense solar phases. The data gathered by these instruments uncovers insights into magnetic configurations, electrical currents, and the spread of electromagnetic waves, phenomena that had only been hypothesized before. Yet the most captivating element of this cluster lies in how it illuminates the ever-shifting dynamics of our nearby space neighborhood. The solar system doesn't consist of a fixed array of worlds drifting through void emptiness. Rather, it's an intricate web of electromagnetic interactions where intruders from beyond our stellar boundaries can alter the state across the entire heliosphere. The gathering of 7 separate comets at the height of solar cycle 25 offers a spontaneous cosmic trial that no earthly invention could mimic. Every body adds its unique electromagnetic imprint to the broader heliospheric setup, potentially shaping phenomena from solar weather fluctuations to the faint magnetic auras enveloping our world. During the height of activity in late October and November, Earthbound watchers will observe the grand machinery of the heavens operating on a magnitude seldom experienced in a single lifetime. Several comets sprouting tails at once, solar weather disruptions triggering outages, and the interactions among varied plasma zones, all unfolding amid a sun growing ever more turbulent. The 2025 comet cluster goes beyond mere sky-watching novelty. It provides a glimpse into the core mechanisms dictating how substances and forces interact in the void encircling our central star. Insights from these sightings will reshape our grasp of topics ranging from the birth of worlds to the feasibility of journeys between stars. The spectacle is only getting underway, with the cosmos extending prime viewing spots to all who gaze skyward and tune into the stellar spectacle above. Part 12. The Energy Surge. An unseen tempest is gathering near Earth, dwarfing even the fiercest tropical cyclones in its might. With solar cycle 25 building to its climax, our star is unleashing a barrage of electromagnetic power that strikes roughly every 11 years, and occasionally over far longer intervals. This isn't mere uptick in solar output, it's a profound overhaul of the electromagnetic shield and surroundings safeguarding our planet. The figures paint a picture that's equal parts alarming and enthralling. Counts of sunspots have risen consistently through 2024 and 2025, surpassing what most experts had anticipated. The Solar Dynamics Observatory records daily views of the sun's exterior, churning with magnetic intricacy. enormous areas where flux lines coil and knot before bursting in cataclysmic force. Every solar outburst unleashes power on par with billions of atomic bombs exploding at once. The biggest X-class incidents propel ionized matter and electromagnetic bursts throughout the solar system close to light speed, generating effects in our planet's magnetic shield that linger for days or even weeks following the outburst. Yet, solar maximum involves more than just these spectacular blasts. The very essence of our star transforms amid these intense phases. Solar wind turns erratic, alternating between swift flows from crown holes and thicker, sluggish outflows from dynamic zones. The heliospheric current sheet, that immense spiraling band of electrical flow stretching from the sun's midline, grows more twisted and elaborate, spawning zones of electromagnetic chaos across the near-solar realm. This is the setting that 3I Atlas and the Comet Cluster are navigating as they near their innermost passes by our star. Far from the calm, foreseeable space weather of solar minimum, they're probing a heliosphere at its most vibrant, electromagnetic rage. The historical context lends gravity to our current observations. Solar cycle 25 marks the initial solar maximum following the advent of advanced space weather surveillance. Earlier cycles relied on sunspot tallies and terrestrial magnetic readings, yet today, we benefit from probes scattered across the solar system, delivering instant insights into phenomena once hidden from sight. The Parker Solar Probe has approached the Sun nearer than any artificial craft ever has, directly collecting solar wind from its origin and uncovering magnetic configurations that defy existing theories. Meanwhile, the solar orbiter delivers synchronized views from varied angles, generating 3D visualizations of how solar wind develops as it spreads through the heliosphere. This superior observational power allows us to witness intricacies of solar maximum unseen by past eras. The intricacy is overwhelming. Magnetic lines that link and reshape in mere minutes, acceleration of particles that propel solar wind speeds beyond 700 kilometers, alongside electromagnetic waves that travel vast cosmic spans. Upon reaching Earth's magnetosphere, these dynamics can yield dazzling yet occasionally troublesome outcomes. The geomagnetic disturbances of 2025 have sparked auroras observable as far south as the Corollas, even as they interfere with GPS signals and trigger slight variations in power networks. The G4 intense storm from early 2025 highlighted the fragility of our tech-dependent systems to space weather impacts. Airlines rerouted flights over the poles to dodge radio failures, and power companies from Canada to Texas noted heightened induced currents in their lines. Yet what elevates this scenario to special interest is that we're facing more than standard solar maximum activity. The gathering of several comets, spearheaded by an interstellar intruder boasting an extraordinary electromagnetic signature, is forging space weather events without prior parallels. Every comet in this cluster functions like a plasma sensor, gauging and reacting to solar wind in the moment. Their enormous comas form zones of interplay where magnetic fields might intensify, concentrate, or alter in manners still largely mysterious. The overall impact resembles several tuning forks vibrating together in a vast cosmic resonator. Conventional space weather models depict a unidirectional flow. The Sun influences the rest of the solar system via radiation and particle flows. However, the arrival of these immense comet plasma formations points to a richer dynamic, where heliospheric bodies can shape space weather via reciprocal processes. 3I Atlas, with its coma extending across hundreds of thousands of kilometers, constitutes a major disruption in the nearby electromagnetic field. Its encounters with solar wind produce bow shocks, field bends, and particle boosts that reach well past the observable coma edges. When numerous such entities function at once amid an already chaotic heliosphere, the aggregated impacts might, in theory, alter space weather across the inner solar system. This remains unproven territory. It's pioneering inquiry that stretches our grasp of electromagnetic behaviors on interstellar levels. The societal and mental aspects of this electromagnetic tempest warrant attention too. Across human annals, eras of atypical sky events have aligned with profound societal and governmental shifts. The while correlation may not equate to causation, it underscores the profound link between celestial cycles and human awareness, a bond acknowledged by societies across the globe for thousands of years. Today's alignment of peak solar activity, a flurry of comets, and widespread societal unrest is forging circumstances that feel eerily predestined for pivotal moments in history. Deciding if this signals true cosmic harmony or mere chance hinges mostly on one's outlook regarding the potential ties between heavenly and earthly dynamics. Looking solely at the physics, bursts of solar energy undeniably alter our planet's electromagnetic field in ways we can quantify. The worldwide electrical network comprising flows of charge linking the upper atmosphere to the ground reacts to shifts in space weather, producing alterations picked up by precise detectors everywhere. Certain scientists suggest these flux in electromagnetic fields could impact living organisms, spanning from microbial reactions to the workings of the human brain. Though the processes are still hypothetical, experiments in controlled settings have shown that life forms react to magnetic field shifts on par with those from major geomagnetic disturbances. Should these impacts hold true, eras of heightened solar output, such as the ongoing cycle's crest, might hypothetically affect aspects ranging from emotional states and mental sharpness to group dynamics and choices we make. This concept lingers at the edges of accepted science, yet it hints at routes by which stellar occurrences could shape events down here. The notion of an energy wave fits especially well once you factor in the sheer scale of power at play. In a fierce geomagnetic upheaval, the overall electromagnetic force surpasses humanity's total power usage by magnitudes. Far from vanishing without trace, this force engages with all manner of conducting setups across and beyond Earth. Electrical networks face surges that harm key components and spark chain reactions of breakdowns. Underground pipes endure heightened wear from stray currents coursing through them. Likewise, our own neural pathways, buzzing with biological impulses, sit immersed in this unseen sea of magnetic flux. With the height of this alignment nearing in late October, the strength of these engagements is bound to ramp up. Sunspot activity tends to stay high for extended periods near the solar peak, as the cluster of comets hits its zenith when they swing closest to the sun and sprout their fullest heads and trails. Together, this brew forms something akin to an ideal tempest in cosmic meteorology, a barrage of magnetic influences clashing at once amid the already supercharged backdrop of maximum solar output. Outcomes might span from vivid northern lights and better data collection for researchers to graver interruptions in tech setups and vital networks. Beyond a mere captivating skywatching phase, what unfolds now serves as a trial run for the magnetic frameworks underpinning our world's protective shield and the gadgets fueling contemporary life. The outcomes will refine our grasp of these interplays and reveal our susceptibility to upcoming solar storms. This surging energy wave gains momentum from powers dwarfing any human sway or intervention. It's up to us to watch closely, record diligently, and probe the implications of these stellar forces for Earth and our spot in the grand magnetic orchestra of the Sun's domain. Viewing it as a dire alert or a rare chance boils down to how one sees our bond with the universe. Yet one fact stands firm. We're on the cusp of space weather unlike anything before. This generation has witnessed events of unparalleled magnitude, and the information we gather will shape our comprehension of these occurrences for years ahead, part contemporary disarray. The cosmos often displays an odd knack for synchronization, yet September 10, 2025, stretched the limits of what logical thinkers could brush off as simple chance. Right at AM Mountain Daylight Time, instruments monitoring earthquakes in Utah's Wasatch Fault area detected a 4.1 magnitude quake. The epicenter lay 15 kilometers southeast of Salt Lake City at a shallow depth of only 6 kilometers, aligning seamlessly with the typical conditions in a zone where geological pressures accumulate like steam in a boiler. Yet, this is where logical accounts collide with unsettling chronology. Less than 4 hours following the Earth's rumble, the identical state experienced an incident that rippled through an already divided political landscape. An effort to assassinate a polarizing personality unfolded at a public gathering. Authorities captured the perpetrator swiftly, though the episode etched yet another divide into a society tilting toward radical edges. Two happenings, one day, one location, lacking any clear link beyond the dictate of time and shared locale. Still, when probing instances of alignment amid surges in electromagnetic disturbances, even the most doubtful analyst starts to ponder if subtler forces might surge below the veil of seeming chance. The seismic event was unremarkable by Utah's benchmarks. The Wasatch Fault Network has produced comparable jolts for thousands of years, fueled by the persistent stretching of the basin and range terrain. As the continent's western frontier persists in its intricate tectonic ballet, quakes of magnitude 4 strike about every couple of months here, raising no atypical alarms for officials or locals. But, as the adage goes, timing holds all the power. That September day aligned with a phase of intensified geomagnetic unrest, trailing a G3 storm that had recently traversed Earth's protective field. Streams of solar wind stayed agitated, with repeated fast-moving flows from enduring coronal voids, stirring persistent electromagnetic unrest in the surrounding space. At the same time, the political episode arose amid escalating societal strains that had mounted all through 2025. Indicators of division rigorous assessments of how fragmented views have grown on vital topics have climbed to peaks unseen since the times of the American Civil War. The botched killing marked merely the most recent in a string of aggressive episodes that appear to mirror profound unrest coursing through modern life. From a strictly numerical perspective, the near-simultaneous happening of a tremor and a noteworthy political disturbance in the same area establishes zero evidence of direct ties. Utah endures steady ground movement owing to its plate boundaries, although outbreaks of political aggression have grown alarmingly routine nationwide lately. Spotting overlaps in timing between such matters turns nearly unavoidable during deliberate searches for trends in the records. Yet, spotting patterns is precisely what renders the human mind adept at handling intricate settings and vulnerable to perceiving bonds that might not truly hold. When striking incidents unfold in tight temporal and spatial closeness amid amplified space weather, our mental frameworks instinctively hunt for ties that forge sense from them. The key difficulty rests in separating genuine links from mere data illusions. Seismic records log thousands of quakes each year as societal frictions spawn countless notable clashes over any 12 months. The chances for seeming alignments abound. Human minds often perceive vast links among isolated occurrences, even when no actual ties bind these apparently unrelated happenings. Yet, certain experts examining electromagnetic influences on living organisms and societal dynamics propose that intensified space weather episodes could genuinely shape both seismic and human behaviors via interconnected pathways. Geomagnetic disturbances have been shown to impact brain activity in vulnerable people. In theory, identical electromagnetic shifts might subtly tweak the tension zones that dictate seismic triggers on fault lines, though these ideas are still largely unproven and debated among scientists. Variations in the planet's electrical framework could potentially modify brain signal rhythms, thereby affecting emotions, choices, and group interactions. Those same fluctuations might also disrupt the chemical reactions governing stone durability and liquid pressures within dynamic fault zones. Should these influences prove real, they would probably operate gently, tipping already precarious setups toward thresholds without inventing fresh dynamics. A person driven by ideology could find themselves marginally more inclined to act amid electromagnetic turbulence, just as a stressed tectonic line might edge closer to rupture under particular solar conditions. The incidents in Utah highlight the immense difficulty of probing these ideas through rigorous science. Both the quake and the violent episode unfolded in scenarios where they were predictably probable anyway. The Wasatch Fault produces steady tremors owing to its terrain, and today's charged political atmosphere has sadly boosted violent acts in numerous areas. Far less disputed is how space weather visibly hampers tech infrastructures that now underpin social exchanges. Such storms can scramble GPS signals, jam satellite links, and trigger electrical grid issues impacting everything from stock exchanges to online networks. In times of heightened solar flares, these tech glitches can ripple across linked systems, worsening underlying societal strains. Automated trading systems might glitch amid weakened GPS clocks from solar interference. Vital alert networks could break down right when urgency peaks. Amid turmoil, social platforms might suffer blackouts that block info sharing during spikes in public anxiety. The September occurrences aligned with a surge in electromagnetic flux. Although direct tech hits were mild, the buildup from various minor hitches could in principle heighten the societal pressure that boosts odds of major incidents. Outside Utah, comparable seeming alignments have surfaced across 2025 in diverse global spots. Odd earthquake patterns have overlapped with civil disorders in multiple areas. Bursts of fierce space weather have lined up with rises in indicators of public friction and governance turmoil. And the international rallies that flared amid the G3 storm era offer yet another intriguing case. Though the root societal issues predated the solar event, the synchronization of mass protests over several landmasses with days of strong geomagnetic flux points to potential links deserving thorough research. But the key issue remains. Are we observing true alignments between celestial and earthly affairs, or just succumbing to our innate drive to spot designs during times of intense celestial spectacle, such as the ongoing comet alignment and peak solar cycle? People tend to notice patterns more acutely and view them as significant omens instead of mere chance occurrences. As we near the October alignment phase, where various stellar influences coincide amid maximum solar output, anticipate a surge in these seemingly meaningful alignments surfacing amid the disorder of everyday life. The real difficulty involves striking a careful equilibrium between prudent doubt and receptivity to ideas that could upend our standard views on the interplay between heavenly and earthly forces. Part 14. Archetypal Transformation, Demise, Renewal, and Profound Accountability. A deep change ripples through the shared human mind when the heavens erupt in extraordinary displays. Across eras, epics of fervent skyward turmoil have aligned with sweeping evolutions in how civilizations perceive their identity and role within the universe. The alignment unfolding toward the end of 2025 embodies every classic indicator of these pivotal junctures: the demise of outdated habits, the emergence of fresh opportunities, and the uneasy interim where unwavering accountability serves as our sole guide. October 21, 2025, signals a new moon, pinpointed by experts through exact computations, yet laden with emblematic depth that goes beyond basic orbital dynamics. This monthly lunar fresh start happens right as several stellar elements unite in a grand cosmic harmony of rejuvenation. The synchronization appears nearly directed by an otherworldly awareness, although experts remind us to resist ascribing purpose to what may just be an extraordinary fluke. The symbolic lexicon of demise and revival echoes across global traditions because it mirrors recurring motifs in the rhythms of the natural world. Grains must break down prior to germinating. Wildfires scorch away debris to foster fresh vegetation. Single cells perish to allow whole beings to regenerate. Such cycles function across levels from the tiniest particles to vast star systems, implying broad laws that shape evolutionary shifts everywhere in creation. Within the mythic lens that numerous societies link to stellar phenomena, the star group Virgo evokes gathering crops, wise judgment, and the meticulous groundwork essential for fresh starts. From a scientific vantage, the true outlines of star patterns diverge sharply from their zodiac versions, yet the mythic essence highlights motifs of cleansing and revival that fit our present era strikingly well. What elevates this era's importance isn't solely the skyward happenings, but the backdrop against which they play out. Our species stands at an intersection where diverse threats collide. Ecological threats, tech upheavals, societal divides, and the enduring puzzle of whether we can advance past our present constraints before those constraints turn disastrous. The notion of profound accountability arises organically in these clustered crises. When surrounding conditions turn turbulent and erratic, the sole dependable anchor is our ability to decide our reactions to unfolding events. This doesn't involve mastering results, which lies mostly outside personal reach, but rather claiming complete authority over how we react to unmanageable situations. Profound accountability demands rejecting the soothing myth that we are mere bystanders to outer forces. It calls for recognizing that our viewpoints, analyses, and reactions to events are decisions we craft in each instant, even if they seem instinctive or fated. This transition from instinctive reactions to deliberate awareness might embody the deepest evolution. Evolution is accessible to individual humans. The process of integrating the shadow gains special importance amid times of widespread tension and division. As communities split into rival factions, groups often cast their own unrecognized flaws onto adversaries, fostering loops of reciprocal vilification that hinder real dialogue more and more. The alignment of cosmic forces presents a chance to spot these projection mechanisms and recover the disavowed shadow elements. Engaging with the shadow is rarely enjoyable or easy. It demands facing the aspects of ourselves we'd rather reject or overlook, the potential for self-interest, harshness, unawareness, and harm inherent in all people. Yet without confronting these traits inside us, we stay prone to enacting them blindly while morally denouncing their appearance in others. The divisions seen in modern culture mirror this large-scale collective projection of the shadow. Rival politicians turn into nightmarish stereotypes instead of people with varying views and goals. Online platform algorithms intensify this by building insulated bubbles that solidify current convictions and vilify differing opinions. Escaping such traps calls for what certain teachings describe as bold empathy, the readiness to offer true empathy even to those whose deeds we deem unacceptable. This involves neither approving destructive actions nor dropping necessary limits, but instead affirming the common human essence that persists even in the misguided. The element of love and pardon and profound accountability might be its toughest part. True forgiveness doesn't involve absolving wrongdoing or acting as if wrongs never happened. Rather, it means letting go of the poisonous weight of bitterness, which damages the one holding it more than the offender. It entails seeing that clinging to rage and animosity only sustains the destructive patterns we profess to reject. Such pardon reaches beyond others to, above all, ourselves. The drive for flawlessness that fuels so much personal pain arises from failing to embrace our own shortcomings and errors. Embracing deep accountability means welcoming our human nature, our proneness to faults, development, and change, free from self-loathing or false illusions. In eras of cosmic alignment, such as the present, paths to heightened awareness speed up significantly. The heightened electromagnetic field could subtly affect brain activity, easing access to broader perception. The emblematic force of heavenly occurrences opens doors in shared awareness, enabling profound realizations in life-altering moments. However, these openings demand proactive involvement, not mere anticipation. Celestial influences create supportive settings for advancement, yet personal decisions and dedication are vital for any real shift. The cosmos might extend calls to advance, but we decide if we'll heed them and undertake the necessary labor. Applying these ideas practically starts with basic everyday routines that build mindfulness and accountability. Contemplative exercises like meditation foster the skill to watch our thoughts and feelings without total immersion in them. Keeping a journal can reveal hidden biases and automatic responses that usually run unseen. Bodily routines linking us to nature's flows, such as being in the open air, consuming foods in season, and syncing rest with lunar phases. Cycles offer a way to align personal awareness with broader universal rhythms. These methods aren't esoteric mandates, rather, they're straightforward approaches to recalling our deep interconnection with expansive natural frameworks. Participating in communal activities delivers crucial stability for processes of archetypal change. Personal realizations without shared communal outlets tend to stay theoretical and lack real impact. Discovering avenues to make genuine contributions to group welfare, be it via volunteering, creative endeavors, or just being genuine in personal connections, assists in weaving profound shifts into everyday life. The cycle of death and rebirth demands shedding ties to outdated self-images and habits that hinder our greatest possibilities. This could involve abandoning professional roles that now feel restrictive, relational habits that sustain hidden tensions, or convictions that curb our ability to expand and contribute. As October 21st draws near, trailed by the height of the alignment phase when 3i Atlas hits its closest solar approach, the archetypal call grows ever more evident. Traditional human behaviors, marked by instinctive reactions, blaming others for inner shadows, and a mindset of helplessness, no longer suffice for today's demands. This celestial alignment supplies potent emblematic backing for opting into deliberate growth, yet true change boils down to a personal decision everyone must embrace on their own. The cosmos might deliver supportive circumstances and metaphorical nudges, but advancing awareness truly calls for bravery, dedication, and unflinching truth about our past selves and future potentials. The core issue we face isn't if stellar occurrences shape human awareness, but if we possess the insight and fortitude to react to any such forces in service of the ultimate benefit for all earthly existence. Part 15. Conclusion: The Cosmic Voyage and Realization. We now linger on the cusp of November 2025, after observing one of the most spectacular astronomical eras in recent times. The evidence stands firm. Our star has stirred from dormancy, with solar cycle 25 hitting record-high intensity. Several comets, among them the third verified interstellar traveler, 3i Atlas, have streaked the skies with glowing trails of ionized gas and particles. Our planet has echoed back with tremors, from the enormous 8.8 magnitude quake in Kamchatka to ongoing ripple effects that underscore the immense powers churning below the surface. Yet, as our inquiry wraps up, we grapple with a deeper puzzle beyond mere causal links between these happenings. We must scrutinize how we handle data amid cosmic surges and what that discloses about the essence of human perception. The cosmos seems to be running trials not only in stellar physics and earth sciences, but in the core of perception and sense-making. The array of ideas we've delved into spans from verified science to the most imaginative hypotheses. Solar Cycle 25 has outpaced initial projections in vigor, sparking G4-level magnetic disturbances that have interfered with tech infrastructures and lit up northern lights in regions well beyond their typical icy realms. The lineup of comets we've followed, from 3i Atlas, boasting a vast envelope half the sun's width, to Swan's striking tail, catchable with binoculars, comprise authentic sky events recorded by bodies like NASA and the European Space Agency. The quake series in Kamchatka, Utah, and various volatile zones have been accurately gauged by arrays of precise detectors, confirming their reality and scale without question. The temporal links to space weather. Although these occurrences are fascinating, they stay within the domain of mere statistical oddities instead of proven cause and effect links. Scientific inquiry requires far stricter proof than just timing overlaps, regardless of how striking the alignments may seem. Still, while we rightly question direct causal ties, our exploration has uncovered something truly significant that goes beyond the particular assertions we've scrutinized. The act of monitoring these associations has illuminated how people's awareness reacts to eras of stellar spectacle, and the reasons those eras have often aligned with major shifts in culture and society. In moments of stellar fervor, our innate ability to spot patterns ramps up, seeking out links in significance that might otherwise go unnoticed. This amplified alertness doesn't represent a weakness in how we think. Across human evolution, times of ecological pressure were exactly when noticing faint associations offered key benefits for staying alive. Our minds could be wired to pick up on relevant configurations amid stellar events, because those configurations mattered greatly to our forebears. In today's world flooded with information, the real difficulty is separating true signals from irrelevant clutter when our pattern-spotting mechanisms are in overdrive. The endless stream of updates from worldwide networks ensures we're tuned into many more concurrent happenings than folks from earlier times ever were. The chances for seeming coincidences skyrocket when you're following quake records, solar weather metrics, political shifts, and sky-watching data as they unfold. This setup brings both an extraordinary chance and a serious risk. The chance stems from our ability to track links across various fields with exceptional accuracy and breadth. For the first time, people have access to such granular, up-to-the-minute details on solar system states, earthly seismic activities, and global social trends. Should there be real ties between stellar and earthly phenomena, no prior era has equipped us as well to spot and grasp them. The risk comes from our vulnerability to data deluge and mistakes in linking patterns during these alert phases. When it feels like all things interconnect with everything, real discoveries blur with intricate flukes. The brain's impressive skill at uncovering patterns can turn into a drawback when it imposes those patterns on scattered or loosely related information. Yet the deepest revelation from our study involves the bond between stellar happenings and human ingenuity. Looking back through history shows that phases of vigorous sky events have repeatedly matched surges in artistic, scientific, philosophical, and technological advances. Whether this points to direct effects or merely the motivating force of vivid heavenly shows, the link implies that stellar alignments like the present one create special windows for broader perception and imaginative output. Peaks in solar activity, in specific, appear to align with boosts in creativity and invention, spanning diverse areas. The intensified electromagnetic surroundings could subtly affect brain processes, easing fresh realizations and unexpected ties between disparate ideas. Or perhaps the emblematic force of stellar theatrics just grants mental leeway to venture beyond standard limits. Regardless, the useful outcomes are identical. Eras such as this ongoing alignment provide ideal settings for artistic pursuits, educational pursuits, and awareness expansion. Expansion practices. The heightened electromagnetic field, whether via direct physiological impacts or metaphorical motivation, seems to promote the sort of unconventional cognition that sparks true breakthroughs and revelations. For those who've tracked our inquiry since its start, the challenge now is incorporating these understandings into everyday routines. The celestial alignment of late 2025 presents a rare testing ground for broadening perception, yet the concepts we've examined stay applicable well beyond the moment when 3I Atlas finishes its pass by the Sun and the comet cluster scatters across the distant solar system. To put these into action, start by establishing dependable channels for monitoring the occurrences we've covered. The Space Weather Prediction Center of the National Oceanic and Atmospheric Administration delivers live updates on solar events and geomagnetic states. The United States Geological Survey keeps extensive records of earthquakes with instant notifications. Apps and online platforms for astronomy provide in-depth data on comets, planet alignments, and various sky happenings. However, data alone, without wise judgment, turns into just distraction or a source of worry. The essence is building the skill to handle universal data in manners that uplift rather than burden the mind. This involves nurturing something like a universal viewpoint, the knack for staying attuned to grander rhythms and loops while anchored in day-to-day duties. A universal viewpoint entails acknowledging our position inside numerous loops functioning across enormous time frames. The 11-year solar rhythm is merely one beat in an orchestra that encompasses moon phases, yearly shifts, planet orbits, and galaxy spins lasting hundreds of millions of years. Our short lives grant us mere fragments of these vast designs. Still, even limited recognition can yield deep realizations about our spot in the universal scheme. The emergence ideas arising from this probe aren't rooted in fanciful notions or mere wishing. They focus on spotting the boosted inventive capacity that arises amid high cosmic energy and figuring out how to direct it productively. Phases of solar peak seem to heighten both beneficial and harmful emergence patterns, underscoring the need for deliberate guidance of imaginative forces. This involves closely watching thoughts and feelings amid times of intense space weather. Harmful mindsets and knee-jerk emotions might surface with exceptional force under boosted cosmic influences. On the flip side, upbeat goals and helpful endeavors could gain surprising boosts in speed during these windows. As we approach the end of Solar Cycle 25 and the slow spread of the comet group into the outer solar system, the takeaways from this probe reach much further than the particular incidents we've observed. We've gained vital knowledge on the link between universal pulses and human awareness, between sky dynamics and earthly inventiveness, between rational doubt and mystical wonder. The cosmos has staged an impressive showcase of its generative force via the late 2025 alignment. The way we weave in the lessons from this showcase will shape not just our readiness for upcoming celestial shifts, but our potential to engage mindfully in the steady growth of global awareness. As the heavens transform, so do we. The universal odyssey persists, and our part as aware witnesses grows increasingly vital to the evolving narrative of existence across the cosmos.